Okay. Okay. I think we're getting there. All right. Good afternoon. Yes, good afternoon. Oh, wow. Okay. Okay, I think it's working out. Okay. Wait, there's an echo. Okay. Hello. All right. So can you hear me? Yes. Okay, that's good. Part of the delay right now is I'm glad you can hear me. The problem is I can also hear myself. This whole business. So I'm feedbacking myself literally because of these two devices, one of which is the whiteboard. And I am smart enough to have muted myself on the device, but I'm not smart enough to have figured out, yes, I am, how to fully, okay. There was an echo effect on my side, which is exactly feedback, especially if it's an infinite echo. If like I hear myself and then I hear myself again, a little bit lower volume, and then again a lower, which I did because I'm an idiot, because the two versions of me were talking to each other, which is one way to approach a marriage, I guess. But this isn't a marriage, this is a class. All right, so we are gonna start, we're gonna keep moving forward. Logistics first. It is totally possible that you turned in homework number 2, and it's possible that you were among the first people to turn it in, and it's even possible that I even know that, and yet you still haven't gotten it back yet. That is true for many of you. That is, there is no reason for that, again, except that it keeps taking me longer than I think it is to finish them all. So in other words, I only just realized recently that I could start at least grading them in the order they come in, even if I'm not rewarding people or something, or punishing people for lateness. So that's why I even know that some of you even turned it in first, and I could have looked at yours first and didn't, blah, blah, blah. So it's still coming back. So that's just an apology. But if you have not gotten homework number 2 back yet, even though you did it, that in no way means I don't have it or that you didn't do it on time or anything. It just means I'm still behind and still have an illusion that maybe I'll get to it in the middle of this class today. But that's homework 2. Homework 3, I've seen many come in. I'm impressed. I have turned back none of them. So although we're going to talk about it today, but right, you would not have gotten back homework 3 even if you know the president or something of physics, of which there is none. So that's homework. So that also, I know that suddenly last night, after you guys all brought to my attention last week that the one recent homework last week was too much, and then it seemed like I sort of believed you or like took you seriously, and then all of a sudden last night, you may have felt that you suddenly got a huge amount from me, even though it was a Monday night. It certainly would feel that way because I hit you with 2 packets, and one of them is thick in reading. Let me clarify. It was meant to be explicit, but it may not be. The second of the 2 things that I threw at you yesterday was not due today, even in theory, like it's due tomorrow. In other words, I just gave you the next 2 assignments. I hope if you look at it closely, or somehow, I hope Google made that clear. So even in an ideal world, all that would be due today was the first of those 2 things, which was a packet about phase constants. And I think someone is not muted, but it could be one version of me. But someone's talking in the background. Could be my family. Okay. Thank you. Right. Yeah. So the homework that in theory was due today, even itself might have struck you as long or arduous, especially if you feel at all already behind. The bad news is that's true. It was long and arduous. I would not have enjoyed that at all as a student, that packet. It was long and arduous though, largely because it's mostly reading, which is of good and bad value. You know, some people find reading easier and some people find it harder than doing stuff. And then it wasn't entirely clear what aspects of it you really were supposed to do or not, maybe. Like you had to actually read enough to even know when you were being asked things, which is not fun. That whole thing was in theory due today, for what it's worth. But that was a lot. There's definitely no need for more than that in one night, even though these are accelerated classes. Just know, again, even if that felt like a lot, the boom does not drop at the end of today. It's, you know, and we're not necessarily going to go over every bit of that thing either. That is the things will start feeling faster once you feel like you get what's going on. If you don't feel like you know, then pay attention today and stuff. But anyway, I'm saying mostly what's tough about that thing is reading, and the value of reading in physics always comes once you need it. Nobody, like this is why I never talk about the textbook. It actually is the textbook that is assigned to this class. If you want to talk about it, I did choose, it is the best textbook out there for this class, in my opinion. It is a classic. It's as good as they get, and I love it. But I love it every time I go to it for the 90 millionth time to look for something specific that I know what I'm looking for. Of course, I hated it the first 80, 100 times I used it. All reading and all resources should be used the way people use Wikipedia or Google or something when they, or like Khan Academy, when they think they're cheating, which they aren't. All resources should be used like on a need to use basis, you know, like in other words, what I'm giving you that packet for last night. Yes, I want you to read it enough to know what's in there so that when you start moving along in this course, and then you're getting strong enough to know when you're weak on something, like, wait, I just don't get, hold on a second. Can phi be negative or not? That's the thing I don't get. Then you know you could remember it was covered in that packet, and you go back and then try to read that bit on that. Like that's how reading is really done. Everything that you think is cheating on reading is actually the right way to, I don't know what you really think, but I'm saying consider that packet a resource. It might be more valuable as we go, but yes, at some point you're responsible for at least answering the questions in it that were due today that we may or may not get to today. All right, that's on that. And the material will start changing very soon too, for good or for bad, if you're looking for a fresh start or variety. But wait, there's one. But about your homeworks. So again, they're very impressive. One of the reasons it's taking me longer to go through them than I wanted is because they're thick and thorough. Like everybody who's turned in anything I've looked at so far, it looks like a real assignment that's being turned in. It looks like someone's taking themselves seriously and knows some physics. I totally appreciate that, and that's why people are getting 50 so far. And we'll continue to, even if you get answers wrong on the starting with the third assignment, just to be to whatever, starting with the third assignment, because I think I will have said it enough by then. If you don't circle your final answers or somehow, or highlight them, or just somehow make it super clear what the answer is that corresponds to each question, then that I'll start being like, then you can't get higher than 48. I mean, which is just being picky, but just for the perfectionist in all of us, if you want it perfect, the first thing you've got to do is have for each individual part, the actual question and the actual answer screaming out from the page. that's for every like dumb reason that you think. Like it's for every like, because Yaverbaum is lazy and he doesn't even want to look at my actual thoughts. He just like wants to know if I even like address that. Right. There's truth to that. And it's true about the whole world. Like, right. Every one of these homework assignments is just supposed to be a mini exercise in how to publish a paper or what it means to communicate some of your science findings somewhere. Right. And the great thing about this physics at this level now is our homework has fewer and fewer numbers in it, more and more letters. So actually every assignment you do actually in theory is a little mini proof of something that could be, you know, but for the fact that you're not the only one doing it right now, it certainly would be something that you want to publish. Like I figured this out about all springs. And the secret of science publishing or science research is that nobody outside of science knows what anybody in science is actually doing when they do it. And in fact, inside of science, no one knows what any other scientist is doing or even really directly cares until it faces them. And no biologist actually knows what the concerns are in physics, I mean, unless they want to, et cetera, et cetera. So every article that's ever published, anything that's published, or a poster at a presentation is always like, here is the question that I decided was worth answering, and you have to challenge, you know, I challenge you to find out isn't an original question, and here is the answer I found. Like you have to reach out and grab someone to say, this is the question and this is the answer. And that's just totally what homework is. Even if, you know, even if it seems like exercises, treat it that way. And I have to say, I'm saying all this because most of your homework so far really does look like that. Like it's easy to grade and inviting to look at, because even if I don't remember the assignment, you're just making it clear to me, boom by boom, like the issue is what's the position of a mass? Oh, this is what I did. And here's the position. There you go. Like I could find that assignment and give it, I could think it's a good article of physics, even if I didn't know what assignment it was responding to. For the most part, that's what everybody's doing. So I'm just saying, do that to the max all the time. Okay, right, and skip lines between every question maybe or something, just to make it clear, like a paragraphing kind of structure. Just pretend it's an article is what it comes down to. Okay, I think we're gonna start going. Yeah, I think the best thing to do is just now, I'll get questions, but once there are no questions, where I'm going to pick up and start just doing physics now is from exactly where we were yesterday, which is in the middle of the vector discussion. Even though I have to admit, I'm a little uncomfortable because I'll be being redundant of what in theory you could have just looked up of my lectures. Like, so I might be wasting some people's time here. So accelerate me if that's the case. But I want to just finish my brief overview of dot and cross products so we can just bang through that problem on that and move on. However, that is after I get, I'm sure I forgot everything in the world. So questions of any kind before I get rolling, or comments. I'm looking at, we've got like 40 people in the room, whatever that means.
Professor, would you want us to hold our questions for the homework that was due today for after you go over vectors, or can we ask them now?
Oh, I love questions about how to ask. No, that's a great question. It was about the homework that was due today. You mean the phase constant homework? A question about that? That's a great, you know what? Yeah, I would, you're right. I'm really glad you asked. I would love to take that first because I may not get to it in time, and that is actually more directly the material we've been, yeah, sure. If you've got a question about, and this is an announcement to everybody, I think that's a great idea. Anybody who has any questions about homework 3 or 4, I will take them now. That will make it easier for me to go through them without boring you when we get to them. And yeah, I'm just saying this to everybody so you're not jostled by it. That means we're about to talk again about the cosine stuff, and we're putting the vectors on hold for a second. I do think that makes more sense. So yeah, any questions about 3 or 4, I'll take, but starting with this one, which is, I don't even know who, sorry, is that Matteo? No, who's actually asking?
It's me.
It's me. Oh, William. Okay, thank you. All right, so please do ask. Yes, that is a great
idea. My question relevant to the homework when determining the functions, if we're given a graph, is if we know phase shifts are occurring, how do we tell the difference between a cosine and a sine? Because once phase shifts are involved, like cosine and sine are very similar looking.
Yes, that is a great question. And it reminds me of a question that someone asked in the homework that I said to them, please remind me about this in class. I don't know if they're listening, but yes. All right, this is totally worth it. My quick answer is, well, you're absolutely right. Like that observation is true, that once you acknowledge phase constants, once you're allowing for phase shifts as we are, then sine and cosine themselves are only related by a phase shift. So how do you tell them apart? Absolutely true. And that is why ultimately we view sine and cosine as literally interchangeable as long as you adjust your phase constant accordingly. Like sine of, I'll write this down in a second, but I totally agree. And I'm ultimately saying, yes, so you could say there's more than one way to answer any of these questions correctly, and you'd get full credit for any of the correct answers as long as you really did it correctly. Like anytime anybody says x equals a cosine omega t, they absolutely could have said interchangeably x equals a sine omega t plus pi over 2 or minus. And either answer would be fully accepted, and you could work with either one. And there's no difference, right, in the world or in the course. And therefore, if it comes down to that, say you're in the middle of an exam and you're like, wait, he's asking what does the function look like? I mean, I could put a cosine or I could put a sine if I adjust the phase. My instinct is, as physicists, 9 times out of 10, if we're dealing with a physical system like a harmonic oscillator, probably cosine is more directly convenient for precisely this reason, that with cosine you can get away with no, phase constant of 0. So if you can get away with that, that's easier and more convenient, like if there's only one oscillator. But right, whatever works. Does that answer the question, or
Yeah.
is that okay? But that's a great question, because that's part of what we're sort of, so someone else asked that too. Let me try to write this down, hold on. The reason you all can also remind me, like I've noticed when I quickly try to upload these videos, I've noticed you can remind me if I start talking about something, even if you think it's meaningful, if I'm not using the screen, you guys can remind me, and then I can turn off the screen, because I think it takes over everybody's visual space when it's just sitting there dead. But what he's saying, and sorry, that's William, right? Who's
Yes.
just asking? Okay, so no, it's a great question that he's asking, and someone asked something related but different in the homework that I've only now just.
Question.
That was you. Oh yeah.
Yeah.
Sorry, Madeline, right?
Yeah.
Sorry, so keep talking. I'm sorry. I agree, it was you, but keep going. Sorry. Say.
Well, I ended up just going with cosine, because if you're trying to like order the graphs based on phase constant, then
Right.
like you should use one function. So either
That's
like all cosine or all sine. But then my other question was, because you're finding the function of each graph and the phase constant is a delay or head start,
right.
like it would be the same graph if it was like, because you can change the phase constant by adding the period or subtracting the period. So if you like add the value of the period to the phase constant, it would be greater. So like it's hard to compare phase constants. Like you
Okay.
can keep changing the phase constant, I felt like.
Yeah. Okay. So I definitely agree with. Again, right. This is a great question. Again, this has multiple parts in a way, or there's like multiple observations in this question. And I agree with every one of the observations. And let me tell everybody too, when, believe me, when I disagree or when I don't like something, you'll know it. And so when I do like something, I like to make it super clear. When I say I agree with something this excitedly, it means not only do I agree, like, yes, that's true, but I also think, yes, that is a fruitful, productive truth path to follow. So like, that's the excitement. And so, yes, a number of the observations that are being made by William and Madeline while like they do their homework, while they're doing these things, they're noticing things that are making it tricky or weird or annoying or possibly even seem unfair, which is all what you should be tracking when you do this stuff. Like, that's why you're ever always, well, anyway, that's what you should be tracking. I agree with all the observations. There's one, and they all lead to one larger thing, which is, whoa, in a way, this phase constant gives us more freedom to express, like to transform graphs and to express them. Like having this constant in there, this placeholder, is like giving another knob by virtue of which we can play with these graphs and study them, and make two similar when we want or two different when we want. And by the way, it's exactly a knob if you ever use Desmos software, which I hope you are using in lab. We'll talk about that. It totally literally is a knob when you do these things properly in Desmos, and that it shows how powerful this is. But it also makes for more confusion. By having this extra option, it does make a number of cases overlap, and it makes it unclear sometimes the best way to express something. All of that's true. We're always willing to make that trade of temporary confusion for longer freedom in physics. But there's one possible conjecture conclusion that I think Madeline was testing out that I think I want to disagree with, or at least or maybe I'm misunderstanding it, but by playing with, okay, so let me start with what's on the screen right now. I definitely agree with Madeline and with William that these two are literally two different ways to write the exact same graph, i.e. the exact same motion. They would both describe the exact same oscillator, especially assuming that omega means the same, value in both cases, assuming that omega and phi are constant. In other words, even if I'm really explicit, I'm saying in one case, if phi is 0, and in the other, it's anything else, those two things, sorry, that's not what actually, sorry, what I mean to say is this. Holy Carl. Okay. This is what I mean to say. These two are equivalent. That was a mistake. That was not a joke. Please correct. If you happen to write down and then tune out, that would be bad. Please look at the screen. Mistake was corrected. Dive, you German see. Everybody please do get from street. Okay, anyway, these two are the same. I agree. They're two equivalent ways to write the same thing, which can be viewed as confusing, or in physics, we view that as good. So one might be convenient for some context and the other for another context. Good to know that I've got that freedom. However, and so what it shows is by tweaking the value of phi, like from 0 to pi over 2, you totally tweak the whole name of the graph from cosine to sine. They are interdependent, yes. Like cosine and sine differ only by the matter of the phase constant. However, here's my big however. However, the phase constant, I should do a different color. The phase constant and the omega, they look like they're very interdependent because they're very interrelated. I mean, they're both measured in the same units, but they are not interdependent. And this is the key. These two things, I want to be very careful. And what I'm about to say now is super important. It's not about any human being. I honestly don't care whether, maybe this is in total agreement of everything that Madeline and William are saying, but it is in disagreement with what history believed for a long time and what people tend to believe. So what we need to be super clear about is by tweaking omega, like that's omega and that's phi, those two things are not interdependent. If you add, very specifically, if you take some omega value, like if you look at these equations and just pretend in your mind that omega happened to equal, I don't know, pi radians per second, you could add some term to that. Like you could make it, instead of pi radians per second, you could make it 3 pi radians per second or 3.5 radians per second, or you could add something to that omega and change the value of it. That does not affect in any way the phi value that came after the plus sign, or nor in reverse. Like it seems like it would, because both involve radians. But first of all, in fact, omega is in radians per second, and phi is not. It's just in radians. But much more to the point, like omega is how quickly, is how rapidly, how frequently we're going through cycles, and phi is where we are in the cycle. So if you added a 2 pi to phi, that means that's true, that adding a 2 pi to phi, in other words, you're making it 5/2 pi instead of 1/2 pi, you could do that, and that has a interesting, cool effect of doing nothing, because all this is cyclical. Like that's an observation people make, and realize that there's certain ways to play with phi that end up not, you can give such a big head start that it's no head start at all, because all this is happening in cycles. But anything you do to phi will not affect omega. Anything you do to omega will not affect phi. And that's a corollary, that's another version of saying amplitude, or excuse me, of saying that frequency does not depend on initial conditions. In the same way that you can't tweak x naught in hopes of tweaking, like you can't turn the x naught knob in hopes of making the omega knob turn. And the same thing, you can't turn the phi knob in hopes of making the omega knob turn. Each one of these constants is independent. And that literally is what we mean by harmonic. Like you could oscillate with, and none of what I'm saying be true. You can go back and forth in some haphazard way. But what makes it nice, clean, energy conserving, and clock-like, what makes it harmonic is the independence of all those constants. They're constant, yeah, the independence of the constants. And I know, by the way, I have a feeling I just misunderstood something Madeline said. Probably, I mean, I don't have time to look at, I can't like do the chat while I'm talking, but everything I'm saying is just to make a clear point that is prompted by Madeline's question and Williams. It probably is exactly what Madeline was saying. For all I know, independence of constants equals harmonic. But it's the legendary thing to know. And I love it. I mean, I say this crap, 3 times a day for 27 years. And it gets me excited every time to think this is, okay, you all know the legend or have heard of the apple falling on Newton's head. Okay, it's garbage. I don't even know what that's supposed, like, I don't think it ever happened. No, there's no documentation of that. And I don't know what it would even mean if it did happen. Like, I'm sure apples have fallen on Newton's head. I mean, I don't know but I don't think there's anything really interesting about the apple Newton head story. However, there are some historical stories that are interesting and documented. And one of them is Galileo in the Sistine Chapel looking up and noticing that the humongous, like spectacular chandeliers that are way up in the cathedral high ceilings of the cathedral, he noticed that they were swinging back and forth in the wind because, it's a cathedral, for God's sake, they don't have like air conditioning. He noticed that the chandeliers are swinging back and forth and started conjecturing, and then while sitting in church, so a little scandalous, but maybe he should have been genuflecting, but what he was doing was timing the chandelier swings back and forth and confirming to himself, based on his clock, that each swing, even as the swings got shorter or longer in the wind, i.e. got damped or driven by frictional or enhancing forces in the reality, even as the swings changed in arc length, they didn't change in time. The chandeliers were making a clock. And this is post 1642, pre 1727. This is him noticing the essence of a clock and how it wrapped up inside a pendulum. And it is kind of then, and he writes it all down when he gets home. So maybe he's lying that he was actually in church when this happened, but he then does all the tests and brings to the world pendulum clocks, by virtue of which he measures free fall acceleration on inclined planes. I mean, pretty deep stuff, like the invention of a mechanical clock, in effect. Of course, you might ask, well, how did he time the pendulum swings if he didn't have a clock? Like, how's he finding out to make the first clock without a clock? Very good question. Something to think about. I'll get back to you if anybody reminds me. So the point is, those are harmonic oscillators. And you either already did prove that in lab or we're going to prove it together. But a pendulum is an example of all of this, because it doesn't matter what the initial conditions are, the oscillation rate will remain preserved. That's true here. You can't play with the amplitude, you can't play with the frequency either by giving a little boost in actual position nor in cyclical position. All right, long way of saying that, but that's why we care. So yes, anything that you think of as a sine could be expressed. Let me say that again. No, yeah, anything that you think might be a cosine could be expressed as a sine, as long as you're careful with the phi. When in doubt, if you literally think it's a coin toss of which one to do at any given moment, I recommend cosine as your fallback position, because you'll probably have fewer non-zero terms to deal with, but that's just recommendation. All right, wait, that's a great question though. And I don't even know if I first to Maddie, I'm sorry, is it Madeline or Madeline and William? Any follow-up you want to ask, or like, did I cover what you're at? I mean, either I hit an ant with it. Yeah.
So how do we do the homework then if we're asked to order the graphs based on the phase constant?
Yeah, I would. Right, I would just make any choice that seems coherent and then stay consistent with it, like you did. Like, I think you made the choice to use cosine and then stay consistent with that all the way through. I think that's a perfectly reasonable. You just set a rule for yourself and make it clear and stay consistent. Like, your choice, I think, was you have to pick cosine for everyone. And then I would say, if you want the rule I would follow is all right, for every graph, I'm going to use cosine and then pick the minimum phase value I possibly can in order to be true. You know what I mean? Like, if it's a cosine, if I'm calling cosine and it looks like it really did start right on the y-axis, then phase is 0, and I'm not going to call phase 2 pi. So in other words, there's always more than one choice, but I would make the rule, write it in the minimum way you can, and make them all cosine. Does that make sense?
Yeah, thank you.
Oh, cool. These are great questions. Again, every one of these questions, notice every one of these questions could apply to everybody in the room, right? Like, I don't know, but every one of these questions is just about how to interpret the homework. So no one's admitting any personal defeat by asking them. But I also view every one of these questions as metaphoric for what are you supposed to do in a situation like that on an exam, which I view as metaphoric for what are you supposed to do like in life, trying to get a job or like trying to publish a paper. And so whenever I'm answering, I over answer because I'm hoping, yeah, I would say in physics all the time, when faced with a question like that, make them all cosine and pick the minimum phase value possible. So other questions like this about homework 3 or 4, anyone, or William, sorry, William, you're good, or follow?
I'm good.
Okay, all right, so thank you. Any other questions about homework 3 or 4? I mean, and I guess as long as I'll say, I think I could say this super quickly. 3 is almost like, once you've done enough of these exercises, either in class with me or on homework 2 or in the lab, you get to a certain point where when you look at homework 3, you would think of it as kind of a duh. Like, I'm not saying any of this is easy, but homework 3 is kind of just one example of the straightforward application of this, but it's meant to be just that, like the distilled version of why do we ever care about this? And the answer is that there are systems that you would never ever think look like a mass on a spring in any way. Like, they're not made of metal, they don't have anything coiled, blah, blah, blah. They're not mechanical. But yet, if for whatever reason we have data that then through running it through Desmos or something, we have data that tells us that system is described by this differential equation, which we're now training ourselves to recognize, then we immediately know that system is a harmonic oscillator, even if and we then could predict all of the stuff about it, including, exactly how it's going to move in time. So the point is that immediately upon knowing the lesson of all of homework 3, so if you just get this one line, then you get homework 3. I'm not saying I'm not going to go over it, but all of homework 3 is essentially just really understanding in general that if you ever stumble upon this, and I know some of you have now written this 100 times in this class, that's fine. I mean, this is all quantum mechanics is based on this, all of P-Chem, physical chemistry, if you have to take that for your major, like, it all comes down to really knowing this differential equation. If ever you see, and you're not intimidated by, if you ever see something like this, and that thing in the parentheses is supposed to say omega squared. Of course, that doubly intimidates people because it's an omega. And like, why is it squared? That's Monday morning quarterback. Like, just to make clear, like, just always know that by omega squared, I mean some positive constant that I'm just in advance calling squared because of what I know I'm going to do with it. But if you ever stumble on this equation, right, where you have second time derivative of some variable equals a negative times some positive constant times that variable itself. In other words, the second derivative is linearly dependent on or directly proportional to the variable itself. If you ever stumble on that, the whole takeaway of all of this is we're saying you can immediately know that variable, whatever it stands for, in the case of homework 3, it stands for temperature, I think. But whatever that thing is, automatically, this is true. Oops, sorry. Oh yeah, no, automatically this is true. Generally, if I write it as cosine, phi will be 0, but whatever. That you automatically know you have an oscillator that oscillates according to this thing, and by omega always means the angular frequency, i.e. 2 pi over the period. Like, you immediately know that it's an oscillator, and you know the period of it the minute you see that equation. And in the back of your mind, you're going to know that omega, that constant, which is angular frequency, would have been determined by some physical parameters of that system, such as its stiffness over its mass, or its length over the free fall acceleration on that planet, or something like that. This is just always true, and we're just, as long as you get how to apply that, that's what homework 3 is, just saying. Having said that, if there's no other questions, I'll check the chat. I'm going to go back to homework 2 and just keep going with those vectors. How can you, oh, you can tweet. Yes, that's true. I'm looking at the chat. Oh. Yeah, so to everybody, I'm saying, so again, I'm getting just wrap up questions. And I will say, I totally, well, anyway, so I'm getting, let me answer this last question that may or may not apply to everybody, and then we'll go on. Yes, if you ever want, for any reason, if you have an expression that you know correctly applies to some oscillator, if you have some cosine type, if you have an equation of motion, some variable as a function of t written down for any oscillator, and if it's written as a cosine, but for some reason you want it to be a sine, like, because that's going to be more convenient somehow, very, very plausible, or just because someone wants you to translate it to sine, like teacher or boss, whatever, very plausible. You can always do that. Yes, you can always change cosine to sine as long as you add or subtract pi over 2, you know, to the argument inside. Like, in other words, as long as you make phi positive or negative pi over 2. Well, for that, but then how do you decide positive or negative? Or how do you even do that? Fair question. But let me start by saying, when I say positive or negative, I mean that just in the same way that I mean you could make phi 3/2 over 2, 3 pi over 2, or 5 pi over 2. Like there's actually an infinite number of different values you could assign to phi that would allow that cosine to sine translation, that would compensate for it. But the presumption is we're just looking for the simplest one, right? So in the same way that I could put 3 pi over 2 and change cosine to sine, I don't want to make my life more complicated ever in physics. It's already always complicated enough. So I would choose to put pi over 2 rather than 3 pi over 2. Similarly, as to whether to make it positive or negative, if I have no other considerations, I always would rather not have negative signs. They're there when I need them, but they're annoying. So if all other things being equal, I would just call it positive pi over 2. Now, what does that mean? How, if I had made it, like, what's the difference between plus or minus there? If it literally says omega t plus pi over 2, what that literally means is that the entire graph is shifted to the left by an amount pi over 2 relative to a 0 graph. Like, making a plus shifts the graph to the left, making it negative shifts it to the right. If I ever did care which way I wanted to shift it, then I would take that into account and make the appropriate choice. But in this case, it doesn't matter. Either way, it'll accomplish the same thing. So, but that's how you would decide. I just always go whenever, basically, this is something that happens with physics people a lot. You have a surprising number of choices all the time in physics. And it's actually the presence of choices that intimidate and confuse people because they're not used to that in science. The truth is, once you realize that they are choices, that as long as you make them wisely, like, they're all possibly correct choices, it's empowering, not confusing, once you just get used to it. But at the same time, yeah, the responsibility of physics is all the choices. Like, the hardest part of any homework problem, people always start saying, the hardest part of any problem is not doing it at all. It's setting it up and starting it, right? I mean, that's because that's where you make choices of actually what you're going to do. And that's what we're trying to train here. Last thought on that. No, I'll get to that later. I put a sheet in the stream for everybody. It's streamed, not a classwork, but right before this class, I put a sheet in that, like, once you finally open up the attachment, is called Knowing What to Do When You Don't Know What to Do. Remind me about that. Actually, let me, as long as can I just get confirmation? Did anybody get that in their stream in the Google Classroom? Did you get for me? That's a yes. Okay, thank you. That's awesome. I'm assuming that yes from Sophia is okay. Thank you. Yeah, that sheet is for your reference, for your files, whatever I said. It's kind of cutesy. It's like from a talk I did a number of years ago. So there's a lot of cutesy stuff that you can roll your eyes at, but it's also dense because there's also actually a lot of stuff being said very quickly in there. When we start getting to worrying about tests or things like that, I want someone to remind me, like, we should look at that sheet together so I can at least give you an idea of what the point of it is. Because, yeah, I mean, the hardest part about physics is actually doing it, right? Which is meaning figuring out how to do it when you don't actually know how to do it. But it's great once you accept that. Wait, so that's that. All right, so I'm gonna go back to homework. If there are no other, have I answered all the questions? Is that, if I answered all the questions for the moment on homework 3 and 4? Oh, well, fuck. Okay. Okay. No, very good. All right, I just got one more really good question, so I'm going to answer it. But then I'm going to say too, this question I'm about to answer is a really good question, just like the last one I answered. So I'm saying this as a compliment, but I got to say, I love this chat and everything, but there's, I think you guys, I would definitely take a private chat question from anybody over no question at all. But these are the kind of questions that are totally legit to bring up in the whole class. And it's actually easier for me if they actually are brought up publicly, because then everybody can see the blah, blah. But these are great questions for anybody who's asking privately. It's a little bit easy. Like, please believe me that these questions are worth raising to everyone. And same thing if you raise something like this in the homework, like this is what we're all here for. It won't slow us down. It'll make us learn better, really, really. But all right, so the last question I just got, it was confused. How do you make phi negative? Because I am talking a lot about, I don't really mean to say make phi negative. It's actually a good point in that question. And maybe the person was afraid that they sound like they were arguing, which they're not. But it's like packed into that question is an implication that I am talking too fast about phi. Phi technically is a positive constant, just like omega is. It itself can't really be negative, nor does it ever need to. What I really mean is that inside the parentheses of cosine, you could say it either, one way of thinking of what I'm saying is you could write cosine omega t plus phi, or you could say omega t minus phi. I mean, if that and then either way, phi is still positive, but the point is that you could take that phi and add it to an initial, or you could subtract it from, and then all that the difference that makes is shifting the graph right or left. But 9 times out of 10, because this is all cyclical, the reason that people might be confused about something like that is because they're right. 9 times out of 10, you can't distinguish right from left because it's like forward versus backwards in a cycle. You can't tell the difference, and that's fine. It means you don't have to worry. So either one that's right is right. Like, honestly, like, yeah, your intuitions, I think, behind these questions are the right intuitions. If you can picture what it means to shift the graph over, that's what phi does. If you can picture what it means to make the graph more bumpy, that's what omega does. And if you can stretch the graph in your mind along the vertical axis, that's what amplitude does, for what it's worth. All right, I think I'm gonna, last thing, just as long as I believe that I've now turned back one homework to everybody and half of another homework to people. I've said that, but I also believe that I've posted now actually 3 lectures. I'm not saying they're good. I haven't even and I'm not saying you should have necessarily used them yet, but can anybody confirm that 3 lectures from this class are available? Like, does anybody know that for a fact, that last night's lecture, for example, is actually available? Is anybody, I'm sort of, yes, awesome, thank you. And can I just ask you, that's great, I appreciate it. Were you notified when it became, like, or or you just looked for it? Like, did you know
got
that?
an email and
Wow.
a notification.
From like Vimeo or whatever, like not from Google Classroom.
From Google Classroom.
That video 3 was available. You're kidding. Really? Okay.
Yeah, I think so.
All right. No, I believe you. I'm totally not challenging you. I'm trying to find out well, that's awesome either. I mean, the fact that, and that's great. Oh wait, no, yes, I do. Okay. No, this is good it's good to confirm that it's actually there. It's good for me to know that this is working. And it's amazing. If anybody's getting notification, even better, then that means like that. Okay. I just wanted to know that. Thank you. Blah, 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 blah. But I'm sure there are things that make it easier to watch these lectures, such as if I take the screen off when I remember, so people can feel free to remind me of that. But, all right, but I think now, if there are no more questions, I think I'm going to go back to continue to talk about homework 2, the vector stuff. Is that cool with everybody? I mean, and that's like a shift, I mean, in material, but are we good for the moment? We're definitely coming back to all this, but if I go to, all right, so going once, going twice. So I'm going to go back to the vector stuff, which is like dot product and cross product. While I get this. Oh, wait, am I? Wait a minute. Pardon me for a second. Yes, actually, no. Just before I go back to that. Exam question. I'm sorry. Wow. Okay. Now that's a very fair question. I just got a question that is fair and good, and not to out the person all. And I can see why this one is private, but I have to answer it. I mean, just confirming that our exam is on Monday, right? Totally fair question. And the answer is yes. I believe that's what we all said, that it would be a week from yesterday. That is fairly soon. That is like the class after tomorrow. I mean, it's plenty of time to study, but it's not very much time for me to talk about it. So first of all, the answer is yes. Second of all, I applaud that person for sort of politely or gently reminding me that before time runs out, I better deal with that with you all. That's totally true. And I'll still give myself, at worst, if I don't address it at all tomorrow, then we're moving the exam. But I should, in other words, what that really means is by tonight, you should all have a practice exam that even if you can't fit, you know, even if I can't fully go over tomorrow or you can't finish by tomorrow or something, you should have it in your possession tomorrow. So at least we have something to refer to in tomorrow's class like that. And then you might not get answers to it right away, but you'll certainly have answers before the whole weekend to study from. So all of that, so I just feel gently reminded about all that. And it's a darn good point. Let me just say it again. So yes, you have an exam this Monday. Yes, that means that you should have, but you know, I shouldn't be giving you any more homework now. The next thing I give you for today should be a practice exam for that. I can't promise we spend all day tomorrow going over it, but I promise that you get it by 4 tomorrow so we can refer to it and know what's on it. And then you get answers a little bit later. People can feel free to keep reminding me of that. I totally get why someone would make that private because it's, you know, it's a subject of the exam. It's like always makes people tense. That's fair, but thank you. So feel free. I get why that was private, but thank you. But people can keep, if by the end of this class in the last 20 minutes, if I've said again, nothing about the exam, please someone remind me again. Again, what you'll at least have by tonight is a practice exam to see, blah, 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 blah. And then tomorrow we'll actually address it. Okay, now I do want to go back to the material. Question is, to shift gears and wake us all up, because I've been talking, right now I'm going to give you all like a do now, like a little practice exercise that you definitely have not seen on any of these homeworks. So it's equally fair game for everybody. It's to practice this. It's a little bit out of left field. You'll know that you get this if you could do this. So I'm not saying it's easy, but I want you all to try this just to get perspective on this. And while I do that, I'm going to get myself back arranged to the vector. After we do this, then we'll go back to the vector stuff. But the problem that I want to ask you all to think about is this. Okay, what we're about to do right now, because I feel like there's been sort of a dry, I think we're hopefully sort of all clear where we are in this class, but it's been sort of dry so far. So just, I want to take a momentary sidebar to something a little bit more sparkly or colorful or whatever, which is the issue of air friction. Because what this is about to be is a math problem that will have us practice this math that we're doing now. And some of you may have seen this, but many of you may have never seen this and may go through your whole life never seeing this otherwise. You know, from the beginning of physics, everybody's always sort of bracketing the issue of air friction, right? From the first time you ever think about anything in physics, in like formally say in 6th grade or informally in 2nd grade, like anytime anybody's ever thinking about dropping crap from the top of a building, and there's this idea, oh, everything falls at the same rate, it's a big physics breakthrough, like, but you totally wouldn't think that because, you know, and Galileo's a genius for realizing it because he totally wouldn't think it because it totally does not actually seem to be true at all, because if you drop a feather from a building and you drop a rock, they totally don't fall at the same rate at all, and they don't hit the ground at the same time at all. So of course it is kind of a breakthrough to hear that everything does, because it doesn't. And then from the moment one, when people are trying to explain stuff in physics like free fall and Galileo, they're always like, well, right, that's air friction. Right. You can't drop a feather against a rock because like, that's not about mass or anything. That's like the feather is more buoyant or is less aerodynamic or something. So it floats in the air. But if you took the air away, then you really would have this great physics play. Isn't that cool? And like a lot of us from moment one are like, well, that's sort of cool, but that's also sort of like Smurf Village. I mean, like, yes, that's a cool fantasy world where there's no air. And yeah, we have video games for that, frankly. Like, if I thought you were telling me something about the actual world of science and stuff you could figure out, but if you're telling me the best breakthrough you can have about the real world is imagine there's no air in it, like what real world is that? Like, and science goes on from there. And I have to say, oh, there's a video, this sounds cool. Awesome. Okay. Oh, very, very cool. Okay. So I love this chat from Gabrielle. Oh, no, definitely. Wait. Oh, these are great chats. Okay, going back to these chats for a second. on the exam, yes, thank you for the thank you, totally appreciate that. And yes, although I did say it, you absolutely will, believe me, when I say practice exam, it includes, as part of my promise, solutions, not just answers, but generally solutions. True, I'm saying often I can't promise that I'm gonna go over each solution word by word, especially because your exam will be so similar to it, believe me, that you would almost feel like you were cheating if I did that sometimes. But yes, you get sentence by sentence solutions to all practice exams. You will. You just don't get them right away because I want you to sweat it a bit first, blah, blah, and work together and, and then have the satisfaction when they come out of being like, yes. But yes, you will get solutions to the practice exam. That is a promise. I didn't fulfill my promise until you do. And there have been times where because I did fail, then I postponed the exam or whatever. Not that anybody wants that. But yes, and these are fair. I appreciate that people are putting these in the everyone chat. Feathers and bowling ball, totally psyched. Cool, thank you for the thank you. Totally psyched to see that. I'm glad you did see that. And that's cool, right? And it's right, we're in this day and age now where we both have video games and we have video technology and high technology where, sure, we can convince you more easily of like, stop worrying about air is its own thing. But isn't it funny that you take, maybe it's not funny, but I feel like your whole life as students and then high school students and then college students, you take all this science, especially if you are in this class, you've been doing so much science for so long, and anything that even smacks of physics at all, they're always bracketing air, right? Anytime they talk about a pendulum and they're like, oh, it's gonna go back and forth the same place each time. If there weren't air friction, you're like, yeah, okay. If there weren't air, oh, well, again, we're doing, and it just keeps reinforcing that physics really isn't about the world because you're always discounting this air that actually is always there and someone should be able to deal with it at some point. Well, I wanna say, air is like anything else. It's just another force that is totally dealable once you want to deal with it. And it just gets thrown into the free body diagram and just another factor to deal with when it's making a big impression. And it shouldn't be, and physicists totally can deal with it. And it's not worth dealing with when it's not worth. But the reason everybody brackets it all the time and doesn't actually address it and then sort of is because although air friction is just another force in the free body diagram, the force function itself is a little bit mathematically sophisticated, just like the force function for a spring is one step more complicated than the force function for gravity, right? Like gravity is supposedly a constant, then kx, the spring force actually depends on position. So that all of a sudden makes things just complicated enough to generate this differential equation and have us do all this madness. Well, springs do everything we're saying they do. And when there's air, and so do pendulums and all that, when there's air there, they continue to do that, but then the air does something as well. What the air does is contribute a differential equation that you will now find easy compared to the ones that we've been drilling. Like this, so like literally, the reason everybody never talks about air is because it's a differential equation. So they feel like it's forbidden. But the fact is, it's a differential equation that will make you totally understand differential equations if you don't at this point, because it's nice and clean compared to the oscillator. And so we're going to do it right now as a practice exercise. And if you get this right, you'll really know that you get what I'm doing in the class, and you'll also believe springs more, hopefully. So here's how air works. So the typical force of air is just like a force in a free body diagram. When something's falling, say we have some mass falling. So this is, again, this is a sidebar. This looks like mechanics right now. It doesn't look directly like waves or fields, but it's about the math of waves and fields, and it's, so it is for this course. So consider a free falling object, also good review in all this physics we need. Consider a free falling object for which there's air friction pushing up on the object while it falls. Exactly the arrow that we always ignore up until this point. How does, well, is there, I'm not going to say, imagine that there's tension. I'm not going to put a T there. I'm not saying imagine there's a normal force. There's no normal force, right? I'm talking about something that's falling that has fluid drag, so to speak, acting up on it. Is there a piece of notation or a name for that? Like we write mg for gravity? Yes, there is. It's generally written not as kx, but as kv. A fluid drag force, okay, just like you have Hooke's law for a spring, the force of fluid drag is very, very simple and easy and beautiful to write down. It's just hard to work with if you don't have enough math. The force of fluid drag is always written F equals negative kv. Just like springs are, it's like F equals negative kx. So the negative, just like there is a directional, a fluid drag force is always going opposite to the direction of motion, like any frictional resistance, right? So this is a form of friction, but we're talking about air friction, fluid friction, as opposed to surface friction. It always points in the opposite direction of the velocity or of the motion, so hence the negative sign. It's always, at least when we, the first level approximation is that it's linear, it's directly proportional to some variable, just like Hooke's law is. Only the thing about air friction that's so interesting and so simple, but yet not easy, is that how air friction works is the magnitude of the upward, if anything is falling in air or frankly, or water, in any fluid, the upward buoyant force exerted by the fluid onto the object points against the object's motion and is directly proportional to, largely determined by v, the velocity of the object at that moment. Right? Very simple, like, oh, duh. When you think about it, oh, of course there would have to, like, first there are constant forces that don't care anything about you, like mg. Then there's forces that depend on the function of your position, like kx, like Hooke's law. And then, of course, if you think about it, there'd be forces, or there could be forces that don't depend on your position, but on the first derivative of your position, your velocity. That's what air does, is the faster you're moving through it, the harder it pushes on you, right? And that makes sense if you think about it, because what air is doing, it's a bunch of air molecules that are just playing out Newton's third law against the surface of some object as it plummets through them, like the bottom of a box as it falls down or whatever. The bottom of the box is shoving at all these air molecules. By Newton's third law, they shove back at the box. The faster it's going, presumably the more that it's shoving on these air molecules, they shove back. So the faster, so K is a constant. It's like, good question. K is a constant, like the Hooke's law constant, only this would be this is called the drag constant. It's unfortunate they're both called K, but they're both called K because they're just numbers. This is the drag coefficient, or the drag constant. That means this, like, if for any fluid, for the buoyant force exerted by any fluid on any object, the whole idea is this. If I'm going to be clear, I'm just going to chart the magnitude of the buoyant force against the magnitude of velocity. So I'm not worried about directions here for the moment, but the whole idea behind buoyancy, behind fluid drag, in other words, again, air friction, the very thing that permeates reality that we always ignore in physics, how it works is just like a spring, in a sense, that if an object is not moving through the air at all, then there's no drag on it. If v is 0, then F is 0. As the magnitude of v increases, the magnitude of the buoyant force increases, but in a nice, clean, linear, directly proportional way, i.e. like this. Like, it looks just like the Hooke's law graph, only in Hooke's law, you're graphing F as a function of X. Here, we're graphing F as a function of V. And we find we get a straight line. Beautiful, means it's pretty easy to work with. The slope of that line is what I mean by K. The more buoyant force that's exerted for per unit of additional speed for a given object is what we mean by K. In other words, the aerodynamic badness of an object. K would be bigger for some horizontal piece of paper than it would for some a slitted piece of paper, or than it would for a pebble. It's like 1 over K is the aerodynamic goodness of something. K is measured necessarily in newtons per, not meters, but Newton per meter per second, if you think about it. Okay, now what does all this have to do with anything? I'm saying that's simple to say. Like, the fluid force is very simple. It's just linearly dependent on velocity. Only that it's actually more complicated than anything we've ever seen in physics before. It's one step above an oscillator. And remember that an oscillator got tricky because an oscillator physics says to everybody, you want to know where something is? All you need to know is its acceleration. Let me say that better. You want to know where something's going to be in a few minutes? You just got to know its acceleration right now. Like, if you know its acceleration at some moment, you'll know where it's going to be in a few moments. That's F equals ma. That's what physics says. Hooke's law and springs come along and say, well, that's great, but guess what? In a spring, yes, if you want to know where the spring is at some moment, you got to know its acceleration at some moment. But the whole point of a spring is that acceleration depends on where the thing is at a moment. So thank you very much. It's a circle. Like, that's what the spring differential equation says to us. Acceleration itself depends on position. Whereas we thought going in that we were going to take advantage of the fact that position depends on acceleration. So it sends us in this circle called the differential equation. We have to solve it. I'm now saying same thing happens with fluid drag, only it's a one step, it's a different circle. It's where's the thing going to be? Well, you got to know its acceleration. Well, what's acceleration? Oh, it's rate of velocity change per time. Okay, what's its velocity? Well, unfortunately, I'm sorry. I just said that all backwards. But here, the point is that here the acceleration doesn't depend on position. It depends on velocity. So that's a circle itself. But what do we do with it? We say this. We say, here's what fluid drag is. It's this free body diagram. You got a downward force of gravity. You got an upward force of kV, where K is a constant for fluid drag. V is velocity of the object. Okay, this is what we call weight of the object. And this is what we call the fluid drag of the object. Drag meaning like resistance, and fluid meaning this is what happens in a gas or a liquid. This doesn't, you already know about solid friction. That's mu and all that business. Fluid drag. So what do we do with this? Well, I'll start you off. I'll say what this means is now physics can be done. Like we know F net equals, and please everybody, at worst I'm admitting this is you could say a sidebar, but I'm writing all this down, so it's totally as testable as anything else. Like, I know this is not a homework problem. I don't mean to confuse people. I'm about to ask you to solve this, but then this will become part of our canon of problems that are testable. So I believe everybody's writing this down just as though and I think you are, but please do. If you are, that's right. So it's not off the curriculum anyway. So we got, when I don't know what to do, I always write down something true, like Newton's second law, and I start filling in. Well, that means the sum of all, that means the sum of all forces equals the acceleration independently along each axis, right? It's a vector equation. So I know it means the sum of all, the sum of all horizontal forces produces the acceleration along the horizontal axis. I know, like, that's one thing that F net equals ma means. Now, in this case, that's trivial. I'm just trying to be clear. This is how I always do things. If I don't know what I'm going to do, I just do F net equals ma on each axis independently. Okay, on the x-axis, nothing's going on at all. F net is true, but it's like trivial. It's not helping me. So I go look at the y-axis now. Again, that's my diagram. Here, I'm just recopying the diagram. The diagram looks like this. Oh, that should be. And I know that these two vectors, kv and mg, are definitely anti-parallel. Like, I know that their direction is as I've depicted. I do not know anything about their relative magnitudes. In fact, I know kv is changing in magnitude every moment, right? A free body diagram applies to one point in space at one point in time. I know this arrow is changing all the time because it's got a variable in its name. So I am not trying to say that these two arrows are equal and opposite. Please understand that they're not the same length. They're just arbitrary lengths. But what I do know then is, I don't know what this share business is. Get out of here, you with your sharing. I hate sharing. I didn't say that, but it's true. So I now say, oh, sorry. I now say, all right, F net equals ma along each axis independently. X-axis don't care about, y-axis is what I'm looking at now. So kv is pointing in one direction, mg is pointing in another. Notice, I'm just summing them up. I'm tacitly, I'm saying up is positive and down is negative. I got to say something is positive, negative, but I'm summing them up and always, and making one of them negative. I see there are chat questions. Hold on one second. Let me just get this far and I will get the chat questions. So I have this so far. Again, this is, I meant for you all to do this, but you're still going to do it. I'm almost there. What am I even trying to figure out? I should have asked.
Professor, can you post the notes when you're in class, the notes that you write?
Yeah, wait, this is a great question. Can I post the notes that I'm writing? Totally, yes. I do post them in the recordings, but I know that's not what you're saying. You're saying just the notes themselves.
Yeah, the lab professor did it for us. He actually posted the things that he wrote.
Just the things that he wrote, but yes, I have to just think how to, yes, like as a PDF would be okay, you're saying? Like,
yeah.
Yes, why didn't I think of that? Yes.
That'll be great. That'll be really great.
And you mean like that's okay to do it after the class? You don't need them.
Yeah, after the class. Yeah.
Okay.
Yeah.
No, that's a great idea. And thank you for asking. And yes, and let me say to everybody, hopefully, I'm just assuming this. I don't know why I didn't think of that. But yeah, assuming that should be no problem, and I'd be delighted. And in addition to the recordings, to everybody, everything like that, not only do ask, and if I can, but I'm taking it for granted for the way this class is so far that when anybody asks me something like that, it's like as an enhancement. Like I would not encourage anybody to then start, and I'm not saying he's saying this at all, he's not, but like it would be a bad idea once I start posting notes for then people to be like, now I don't have to go to class because he posts the notes anyway. I think hopefully people could tell from the way I teach, like that's a bad idea because I say so much that I think, you know, people should use it as a reason to listen to class differently and then have the notes for, so that's why I totally will do it. But yes, absolutely, I will do it. All right, moving on. And I'll look at the chats in a second, but I'm really afraid that my train of thought is gonna wreck at the station before I look at the chats. All right, so I'm almost, what am I doing? I'm just like jumping in and analyzing the physics of a free fall, I mean, of non-free fall, of fluid fall, because I'm excited to, but I'm not, I forgot even to mention, like, what's my objective? Well, it's the same as my objective always is in physics. The question I'm trying to figure out here, once I learned a new fact, the question is, what is X as a function of T? Like, again, this is a sidebar exercise, but it's the same question as we're always getting. Like we're used to thinking in science, give us a function and we'll plug in, like, and we'll use it to get an answer. I'm saying here, the real objective in reality is to find functions. Here's a situation where if something were in free fall, we know what the position function is. If it's in free fall, it's x equals 1 FAT squared plus v naught t. We spend the first month of the first physics class figuring that out. But if you throw friction, the reason everybody ignores friction until now is friction adds one term to the free body diagram that then will render that equation of motion, the 1 FAT squared, useless and wrong. We need a new x equals function of t here, given the new force of friction. And this is what I'm about to turn to all of you. So the question that I should have made clear right from the start, but always is the question in physics, is what is x as a function of t given? If given this new idea that the net force now not only is some component of gravity, but also, I know I wrote it the other way, sorry. If, actually, whoa, no, I'm gonna change it. Right? I'll change it in the original thing. If we have some force which is not only gravity, but now also has an additional term representing friction in it, our question here is, given that the net force on something is not just mg, but mg with air friction thrown in, then what's our new force function? That's what I'm trying to find here. That's what I'm gonna turn to you in a second. But one thing I think I made a bad choice a moment ago. Yes, I want to correct one thing. I'm being too glib. This is a perfect example where all choices are equivalently correct, but some are more convenient than others. So you want to make conscious choices. I glibly just decided to make up positive and down negative. Poor choice. Before I go any further, I want to correct that and make up, and I'll tell you why. That could work, but it's going to take me longer that way and be more confusing, and I don't want that. I want to make up for this whole problem. You could do whatever you want, but I recommend making up negative and down positive. And here's why, because this thing is falling. Like we know, if this thing I'm talking about, I'm picturing something falling through air. So it is falling, like it's accelerating down. It's not accelerating in the normal 9.8 way. Like that's what I'm trying to figure out. It's accelerating in some funny new way, but it is accelerating down, i.e. it's going to get faster and faster as it goes down, or if I threw it up, it would eventually come down, right? So since that's its direction of expected acceleration, I'm going to call down positive. That way I can keep on saying, as I've been, F equals MA, as opposed to F net equals MA, as opposed to having to say F net equals negative MA. Like I don't want to just introduce a negative sign right from the get-go that I don't need. So this is a correction I'm making. I really would be more wise for me to write down mg minus kv equals ma. So I'm correcting that on that screen. Again, I'll post these and send them. But I'm saying, given that now, given some net force, this is like saying, given a net force generated by Hooke, we're now saying, given a net force instead generated by gravity and fluid drag, what's the x equals ft function? What is x as a function of t? That's what I want. And early, that's what I'm going to ask all you guys to solve together, like starting momentarily. I'll give you one hint. If you have, like you literally have this is the given again, you have kv. So This is practice in the differential equation stuff. It will not involve cosines and sines or oscillators, but it will involve differential equations. You have this is what I'm saying is the given. I'm saying given that you want together as a group to find x as a function of t. What also is given, like that's the physics that's given. There's no Hooke's law in this. Don't say kx anywhere. But what also is given is just the math of by v, I by definition mean the dx dt, and by a, by definition, I do mean dv dt. So given that, I want to find x as a function of t. A hint might be it might be easier to first find v as a function of t. That would probably be the easiest thing to find first and then go backwards from there. But this is a do now, even if it takes us the rest of this period, you'll really know if you get what's going on. And I think it's really cool physics. I want everybody to work together. I'm going to look at if I can make a break. Oh, I can make breakout rules. Wait, I'm going to look at the chats first to see if there's an emergency intellectual. Stokes law. Whoa. Wait, where's K again? Yeah. You could use C. Okay, wait, I'm looking at. Okay, whoa. Okay, I'm quickly saying before I set you guys loose. Oh my God. All right, I'm looking back at the chats. It's such a different life. God. Videos of feathers and bowling ball, someone suggested. That was cool. And then someone said, okay, thanks to everybody. That was cool. Then somebody put the link or a link and gave credit to someone else, which is so nice, right? Like one person puts this link and totally like shouts out a friend or whatever, someone else, that's cool. Then someone says, I think every physics class I've been in has shown that video. I find that hysterical. And I'm going to take that as like a slight satirical point against all physics professors for being like so lame that way to have the same. But if it was slightly meant as a jibe against the person that shared the link, I want to say, well, that's why then people shrink into private. Please don't do that. I don't think it was. I think it's a jab against physics professors, which is fine. But let's try to be really careful in the chat so that everybody does stay public. But I'm sure that was the link. That's cool. Then someone asked about K. Yes, if you've seen this physics before, any of you, sometimes it's written as F equals negative capital C V. You could totally, wherever I'm writing K, absolutely, you can write C. And the more you want to change anything, and anybody who understands that they can rename constants and rename variables as long as they're consistent, totally, please, right. That's what's happening in physics. Whatever, I can tell you that whatever choice I make, I'm never saying is the only choice. Well, I mean, I don't think is the only choice. Often a choice I make is for a reason. Like the reason I'm not using C is we're going to use it so much in other places. I think it's confusing, but I certainly could have here and maybe should have, and sure. But yes, that is totally what I mean, is that C thing that other people. And then, yes, the main thing is the K that I'm talking about right now in this example. It's very important for everybody to see. The K I'm using right here is totally not K from the spring constant. It's dangerously similar. If we were going to do this there are other Ks that are going to come into this class. I do different handwritings for those so you don't get confused. This one is a one-shot deal problem now. I should have put a different font or something, but yes, just unfortunately, the two Ks are different. They won't mix in the same problem. This K is what someone's calling Stokes law. That's impressive that you know about Stokes, or it's impressive that whatever. I agree. Cool. All right, and then two more messages. Yeah, so I'm saying downward is positive. I originally said downward is negative. I totally think downward should be positive. And not at all. It's fascinating. Ha! Okay. I forget. Thank you for Erica clarifying. Not all fascinating. Fair enough. And of course, I haven't seen the link because I'm pathetic. So I haven't seen the video, so I should. Wait. Oh, my ass off. Right. Yeah. Thank God. So I have this, by the way. Some people even know where I went to college. So I guess so you probably know, I have two sons. One is 16 years old and one is 5.5 years old. Between the two of them is the only reason that I can ever, like, thank God, I think I do know what LMAO stands for because but like, whoa. Yes, they're the translators. Okay, yep, having said all that, you all are gonna go into breakout rooms because for some reason that function has reappeared on my computer. I'm going to put, oh, yes, I'm sorry, yes.
Before you put us into breakout rooms, since you said this scenario is free fall, can we assume constant acceleration or no?
Wait, that's a great question, but I'm explicit. I use the word free fall a lot. So I'm actually explicitly saying this is not free fall anymore. Like it's something falling in just gravity and just air. But the mere fact that there is air means it's technically not free fall anymore. Like acceleration will not be constant. That's what you have to watch out for. That's what you're going to find here. I mean, great question again, but right, free fall technically means if the only force acting on an object is gravity. And here for the first, I don't know if the first time or not, but for here, I'm saying, assume there's in that axis, there's not only gravity, but also this upward force of air friction. So, right, you are going to find out what the acceleration is doing, and you're going to find out that it's not constant. So, good question. And what you're going to do in a second is you're going to get a little notification that says, please move to like breakout room, blah, which just means you press that button. And then what means when you, and please do in a second, you're being randomly assigned to rooms so that there's like 3 or 4 people in a room. The room means, if you've never done this before, what it definitively means is that I'm not in it. Like unless I explicitly enter, and then you'll know that I'm there. The point of the room is that, you know, I'm explaining this to you guys. If you're in a room, it's random, don't take it personally, but you're in with 3 new people that you're just there to try to get an answer or work this through. And I will come through perhaps, but not unannounced. So you're supposed to be as free as you can to like make mistakes or say that the question's unfair or whatever, blah, 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 until I enter in and then everybody gets polite. So just go to the room when it says, and oh, I'll say this too. How much time are you gonna get in the rooms or whatever? Well, this is definitely not a test of anybody. I would prefer that you feel relaxed and not feel rushed. So in a sense, you get as much time as you need. But the one thing I'll tell you is we're not gonna go back and reunite until at least I've seen that everybody has entered a room. Like the clock doesn't even start until actually everybody goes in the room and hangs out there for a while, even if you just sit in silence and agree with one another that you hate each other and just want to work quietly, whatever. But I will see where everybody is. So I want to electronically see that everybody goes into a room and then give them ample time to not feel rushed and talk. So, you know, if you nail the problem in 2 seconds and then want to start talking about whatever homework you all are on, please do that. Okay, maybe you did this already with Woo, I don't know, but here we go. So the rooms, you should be invited to join a room. And if you get moved accidentally, I'm sorry, it just means I saw an issue like I was somewhere and it's not personal. If you get moved, it's not personal. I'm just trying to keep them even. So there should be at least 3 people in every, oh, you can't hear me at this point, probably. Well, if you're hearing me, you're not doing the right thing. If you're hearing me, you should move to a room, please. Like you should press that button that's inviting you to join a breakout room. Thank you. Right, so again, if you're hearing me, there's some invitation that you should be getting somewhere on your screen that says join a breakout room. You should hit that, please. Right, okay. Please join your breakout. So a lot of you are still not, please, if you hear my voice now, please join your breakout room. If you don't see how, send me a chat, but anybody who's hearing me now should be.
We have to, I guess, like distribute the t into the parentheses next
Okay.
to it.
So we have GT minus KVT
Yeah. Over.
over M plus C, I guess. But then if we get rid of the V, wouldn't we just like have nothing?
Right. I feel like it's kind of stuck in there. I don't know.
Maybe?
If you're speaking, we don't hear you. We still don't hear you.
Yeah, are you talking to me
No,
or
that,
to the professor?
and
Cheska? Oh yeah, I see the professor.
Can you,
So you integrated both sides.
so wait, can you stop for a second? You can't
Now
hear
we
me
hear.
still. Can you
Now
hear
we
me?
can hear you. Yeah.
All right, very sorry, but so I'm interrupting. This is a total interruption. I'm sorry. So as far as I understand, I'm talking to Gabrielle, Ariana, Grace, and Cheska. Is that correct?
Yeah. Mhm.
Okay, and I'm totally interrupting you. I know that when I first came in, Gabrielle was explaining something cool, and she couldn't hear me. And then Ariana was talking. You'll go back to what you're doing in a second. Just first of all, I'm making sure this is working. But Grace, you're in there, yes?
Yes.
So your thing about the device was a great point I hadn't thought of, but I think I've dealt with it. I want to make sure if you look at your device like in real life, it got an invitation to join this room now, I think. And if you could hit that, so you could, I'm asking you personally or directly so I want to see if this works. And then that way you could have your device with you and I don't think that you're not in a room, if that makes sense. And as long as that works for you, I'm going to try with other people, but.
Okay. I don't have I saw it in a notification. This one is, I believe this is breakout room 6, and then my other computer was breakout room 5.
Oh, good to know. Hang on one second. All right, thank you for telling me that. 1 second. Well, it says
The participants are the people that haven't joined the breakout room, I believe.
That's weird because on my
I can tell my friend to join one.
Now I'm actually confused. You're definitely telling me something important, but I actually don't get. So you're saying your device. Oh wait, is your
Yeah, I'm
you are
using
Grace Carol? Oh sorry.
Yes, I have one device is Grace, and then the other device is Grace currently now, because I'm
Right,
recording on one device.
No, it's totally fine. No, I think it's great you have two devices. You don't have to justify it at all. It's just what's confusing me is on my side, it believes that your device has been invited to this very room of 6, but you're saying that it's getting an invitation. Oh, I know what happened. Can you like deny that invitation or something, or clear out X out?
I don't see the invitation anymore.
Oh, then
It
wait
disappeared
once.
already.
Now see,
Okay.
I think
Oh,
it's
I
gonna.
see. I see. Join breakout
Okay.
room. I
Okay,
can
so
join it.
Yes,
Should
please.
I just join it?
Yes, please. Yeah, I want to see if
Okay.
this works. And it's fine. Then you're 2 people in the room. But just this will be what we'll do with it. Okay, so now it's there, right?
Yeah.
So if I'm not mistaken, this means, first of all, now you have like full functionality as you wish in your room, and I can leave you alone if I'm not. And it also means, like in the future, in other words, now you're easy because you named them both you. So in the future, I'll just put them both in the same room, and then then I'll know. Then you won't have to explain it. Like you'll be there.
Okay.
And I'll do this for other, so I appreciate it. And I will stop interrupting you all now because it looks like, because you sound like you know what you're talking about. Am I right? Should I leave? All good if I leave?
Yeah.
Okay. All right. Thank you for that. That's good. All right.
Right.
Okay. I'm going to leave. I'm going to join. Yeah. Okay.
Oh, hey. Oh, okay. It's the professor.
Yeah.
Yes, it is right. Yes. Good call. Okay. First of all, sorry to interrupt. I'm totally interrupting. So you.
I have questions. This is great.
Oh, okay, good. So let me make sure of one thing though. Right now it looks like it's just you in this room. Wait a minute.
Oh no, it's there's
Oh,
two of us
Daniel.
here. Yes.
Oh, because your name is Daniel and that doesn't mean me. I'm so egocentric. I thought it was me. Okay. All right. Now, first of all, I apologize. I don't know why there's only two of you. Actually, that's partly why there should have been a third. And 1 second before you asked me a question, let me just see where's it. Oh yeah, because there's a third person who just hasn't joined. 1 second, let me just send a thing to her. Even if and then I'll answer your question happily. So you knew the moment I came in though, didn't like? You could tell the moment I okay. Okay. Wait. Oh, okay. I don't know how to do that. Okay, I can't do. I'm trying to get your third person in there, but all right, whatever. Ask your question, please.
I guess I'll just show you what we have. I'll turn my camera on for a second.
Okay.
I don't know how this is gonna work.
Although you can even share a screen for what it's worth if you want. Okay. All right. Oh, that's not bad. Oh, that looks good. First of all, I totally can see it and read it if that's the question. I mean, once I shut up, I can because I'm on speaker view. Hold on. Okay. Yes. Okay. Wait. A little fast. Could you do one more? Sorry. One more time. One more time. Could you do it one more time? Whenever I talk, it pops out because this goes into speaker view.
Oh, I think there was a different option that allows you to look at all.
I'll just read it to you.
Oh wait, no, do it one more time. Now he's right. I had a dumb option. Just do it one more time because I really can see it.
Oh, okay.
Oh. Almost right track. Okay, I see it now, and you're on the right track, and there is a mistake, but you're on the right track. But okay, ask your question.
So first,
it's good. It's good.
Did F equals KV minus MG, which equals MA. Then we replaced the A and the V with their like respective like what is it,
Good.
differentials or
Right. Good. Yeah. Although one thing, I think it was my mistake, but I think we said actually it's going to be easier if you do MG minus KV. Not. That's what I was trying to. Or did I keep making them? I think it's going to be easier if you make down positive and say MG minus KV. But I think I correct. But yeah, that's
you said it. That's my bad.
Oh, okay.
So,
but you could keep talking anyway.
Like we literally just did not know what to do after that. Like.
Okay, so the first thing you did was right. I mean, even if you switch it around or whatever, but what you did to substitute in the derivative definitions was right. Like for V, for A, substitute in dV over dt.
Yeah.
All right, that was good. And do that. I didn't catch, I forgot to look, but leave V as it is. You didn't substitute, I can't remember, but don't substitute anything for V. So in other words, what did you? Oh yeah, you did the right. If I'm looking at the right, I actually don't know what screen I'm looking at right now, but wait. Hold on 1 second. Yeah, could you show me your thing one more time, actually?
Yeah.
Right, okay. So this is where I'm agreeing with the right side of the equation, like where you changed A into dV over dt. Yes, good. Then on the left, you substituted in dx over dt for V. Like that's true. And it's true that I even gave that information. So it almost accidentally might have like seemed like I was telling you to do that, but don't make that substitution yet. Like leave that alone for now. In other words, you want an equation that has dV over dt on the right side, but on the left side still has a V there. Am I making any sense? Like undo this. Mm-hmm. Okay, because then what you'll have, if you look at it, you're on the right track and you're doing the right thing because you'll have an equation with a bunch of stuff in it, but you'll notice that the only variables in your equation are V. If you do this the way I'm saying, you'll have an equation that has like an M in it and a G in it and a K in it, and those are all constants, so they're just numbers, it's okay. But the only variable you're seeing anywhere will be V on the left side and a V and a T on the right side. In other words, a couple of V's and one T, your whole equation will just therefore have two variables, one dependent and one independent, which is good, like that's what we want. they're in bad places, but at least by making the one substitution of changing a into dv over dt, we'll at least now only have one expression that has literally two variables, one independent and one dependent. And by those two variables, I mean, t and v. We're good so far? Does that make sense so far? And then I'm going to tell you a next step. I will tell you the next step, but then you're going to do it, I think. But are you with me? Oh, sorry. Go.
Are we only allowed to change like one variable at a time? Like we can't.
Well, it's not that. It's not that you're not allowed to change. You can think fast if you can think fast. I'm saying though, you only want what you're trying to reduce the number of variables in your expression. Like whatever you're looking for at this stage, like you in other words, for every one equation, there can only be one unknown. If you have an equation that has like three variables in it, a and v and t, we won't be able to solve it because like two of them are unknown, a and v, let's say, and we only have that one equation. So we actually won't be able to get anywhere. So I'm not saying we'd be skipping too fast or violating a rule if you subbed out the v right now, but I'm saying actually it would be counterproductive. You right now want an equation that just has the time variable in it and one other variable, so that we can relate one to the other. Am I making any sense? Does that make sense?
You're like trying to isolate v, basically speaking.
Yes.
Or like isolate variable.
No, v, in fact, exactly. And that's going to be your next step. And I don't know, wait, is that cool so far, Jessica, what I'm saying? Right? You're fading. I can't hear.
I think she cut off a bit.
Okay.
Yeah, I get.
Oh, okay. Because then we're good. And then what's going to come into play, what Daniel just said, like, I'm going to give you. So now you have a statement that looks at something like, oh, I'm cutting out too. I think I have to change. I'll change my audio. Hold on one sec. Hold on. I don't know if. Well, I'm going to say this quick before my audio. I think you have now something like kv minus mg equals m dv dt. Okay, so in my mind, that means you have a v on the left side and you have a v and a t on the right side. So your next step is you want to just keep arranging things so that all the v's are together collected, including dv. Like if I see something called dv, that is referring to v in my mind. So you want to just rearrange stuff algebraically until all the v's and the dv's are together on one side, or in other words, rearrange things until the dv is with the v on one side and the dt is on the other side. And I don't care, neither one necessarily has to be by itself. All the constants can be wherever you want, but you want to collect and separate the dvv's from the dt's. And then you'll be in a position to integrate. Like that's like the next, that's my hint or does that make any sense? Because I think also my audio is about to cut out. I have to change it, but does that make?
So now I have kv plus over dt equals mg.
Something like that. It's going to be a couple of steps. I mean, I'm not necessarily sure I think I'm going to ask you to do them together, and I may walk into another room right now, but yeah, it will take a couple of steps because first you'll like multiply both sides by dt, but then you'll divide both sides by something like, but yeah, you want to keep playing with it until, and I don't care if v is in the denominator, so like don't get stressed if something's in a denominator, that's okay. But so I'm not actually going to say if you're right or wrong yet. I think I want to fix my audio and walk into another room, but as long as you kind of understand the hint that I'm saying, it sounds like you do, then I'm going to, so I'm literally going to leave because I want to change my audio anyway, because I can't actually hear what's going on and I'm not sure you can hear me. So,
Thank you.
Pardon. Well, thank you very much. Okay,
All right.
Thank you. Well, thank you. Okay, let's see. Oh, hello? Anybody there? Hello? Can you hear me? Test, test. Okay, hello. Hello, Jacqueline. Hello, Rabina.
You can take it.
Okay.
Hello. Okay. Can you guys hear me?
Yep.
Good. Okay. And I can hear you. Okay. Now I've done something. Oh, this is really weird. All right. So I'm on different audio now because my audio gave out. So it's a little strange. My screen is now much bigger. I don't know if this is going to be a good thing or a bad thing. No, I guess. Yeah. All right. Oh, I'm having hard. Sorry, this audio is really bothering me. 1 second. Can you hear me now? Can people hear me now?
Yes.
Okay, can people hear me now? Can people hear me? I actually believe you
Yeah.
can't hear me, but
Yes.
and I can hear you. Say that again, please. That's actually the real thing.
Yes.
Okay, thank
Yes.
you. That's
Yes.
what I'm
Yes.
looking for. I've been lying this whole time. I've had a feeling you all could hear me, but I knew I couldn't hear you, and now I can't. All right, because again, see Gus Johnson, because I can't turn the okay. All right, so those I visited some breakout rooms. I did not visit others. Hopefully next time, it's a scatter shot. It's just like with the homework right now. My first priority right now is making sure everything technically is working or systematically is working. So I visited the rooms where it looked like there might literally be breakout room issues or things I could improve. So if you were doing physics hopefully they worked for you. The amount of time you just all had was sort of just based on how much time I could get around to whatever rooms I could. So we're going to see now what you think about that problem. It's 3 to 5. So we're going to finish this and then get back to the vectors before today ends. And again, today will end in about 5 minutes. We will finish this. We will get back to the vectors and hopefully finish them. We will not have started on homework 3 today. I said something about it, but that's fine. You will not get any new homework. The next thing you'll get from me at some point this evening is a practice test for tomorrow. I'm sorry, a practice exam with reference to the exam that will happen on Monday. The worst scenario that might occur is the following. You might not get this practice exam till super late tonight. I mean, I'm not planning on this, but this is what could happen. You know you're not getting any new homework, and any homework that you haven't done, that's just your next priority to do. But in the worst scenario that you don't get a practice exam till very late tonight or early tomorrow, then it's understood there's nothing you could have done with it by the time we get to class tomorrow. If you get the practice exam late, it's understood that I was getting it to you so that you could have it, and so that by the time we get to class tomorrow, we're all talking about the same thing. Potentially, I might put you in breakout rooms to do it, or blah blah blah. Hang on 1 second. I'm going to answer this. Yeah. Okay, good question about the exam. All questions about the exam, like format, rules, all very fair. And I want to address them as many times as I need to and explicitly, but partly that's why we do a practice exam. It will answer some of those questions. So bear with me. I'm going to say questions like, what are the rules or how long you're going to have to take this? I'll explicitly address tomorrow in class, and by making explicit reference to the document you'll have that will be a model for this exam. And that's the idea. By the time so in the worst scenario, you'll have it too late to do anything about, and that's fine. Understood. But it's so that we all know what we're looking at tomorrow when we prepare for the exam. And that means that you know, I may still spend tomorrow with you looking at this document, and it will still be blank, and you'll get answers, you know, later that night, or, you know, Thursday or Sunday, certainly in time for the weekend, to check things. But again, then tomorrow we'll focus on those details. So don't panic if you don't wait up tonight, like looking for this thing. The later it comes, the less you were expected to do anything with it. But just, okay. Blah, 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 blah. Why am I saying all this? So that, oh, and I'll say this too, because now that an exam is coming, office hours, it tends to be the case that right when this class ends, I'm trying to change this, but I tend to have to hop off fairly quickly. And I think half of you have to go to lab right after this class too. So all the more reason we can't really do Q&A so fairly then. I am going to start some kind of office hour block in the morning for literal Q&A. And certainly there will be one before this exam. But it may be as crazy as like 8:30 to 10 in the morning on Friday, just because of the reality. We're all doing this from homes and stuff. So let me just say here, again, I swear, almost every question I've gotten from anybody so far about exams or grades has been so legit that I encourage you to use class time to ask all these questions. Like they're not, you know, for my money, all of class would just be big office hours all the time, and then you wouldn't have to go to office hours, and I wouldn't have to have them. So please don't be shy about asking the kind of things that people have been asking in the chats and stuff. So that said, I could feel like, that said, I apologize in advance when I hop off at the end of this. That will just be the way it is. But you'll know that you have no new homework except whatever you haven't done, and you'll at some point get the practice exam tonight. And that's what the exam will look like, and we'll get to that. But your exam will look very much like, the longer I take to make the practice exam or whatever revisions I do to it, that's because I'm giving you literally the advanced briefing. We're looking at the actual thing. How much does it differ from the actual thing? Probably by like 15%, and that's in content subtlety, not in formatting. You're not meant to be surprised by the format by the time the real thing comes. Okay, that said, oh my God, 3:15. So back to this fluid drag. I think this is a situation like what you're looking at in the board right now. Again, wait, sorry, people can hear me, right? You can all hear me because now I'm about to talk about physics here. Okay, all right. Sorry, right, this is what we have right now. If anybody wants, since you were in the breakout rooms, before I go any further, does anybody want to try to take a stab? Like, what do you do next? If we're looking for, like, we're looking for X as a function of T, I think we have, physics gives us an equation that relates V information to T information, but it relates it in this bad way that's right there, a differential. Well, yeah, I'm sorry, I should say, what we have here is a differential equation, right? I mean, I can make it even more clear by dividing both sides by M or something. But what we have here, what we want is something as a function of T. What we have, oh, the audio went out. You can't hear. Oh, yeah, wait. Oh, you can't. Hold on. Can you? You can hear. Wait, I actually need. Right. So maybe. So like Aaliyah and Gabrielle, you can hear me. Okay. So that might be on someone else's side, right? Thank you. Yeah, these things are important. It's so weird how. God, sorry. Yeah, you have to understand, when I was growing up, they didn't call it ADHD. They just called it me. But what am I trying to say? I'm trying to say, yeah, we have a differential equation here, right? We're looking for something as a function of T, maybe X, maybe V, maybe, but what we have is dV. dt is a function of something. And again, let me say, if this t term right here, if that were a t, then we would have a differential equation, but it'd be trivial. We would just integrate both sides, not even notice it was a differential equation. We would just have one of these situations where we had derivative information and needed the original. We just work backwards. But the fact that this is a V, this is what makes air friction interesting. Like, not undoable, but just interesting. Air friction pushes harder the faster something's going. But of course, then how fast something's going depends on the rate at which it's accelerating, which depends on how hard it's being pushed, right? Air friction itself is a feedback phenomenon. The faster you go, the more your speed is changing, the more the air friction force is changing. But the more it changes, the more your speed changes. So they're related to each other in this funky way that offhand is not explicitly solvable. But we can solve it because somebody in the class is going to tell me now, like,
Professor, should it be negative mg minus kv?
well, I think, wait a minute, that's very interesting. So I don't think so. Like, okay, good question. We can make whatever choice we want about the coordinate system as long as we're consistent. My recommendation for this, even though I did make a mistake at first and change my recommendation, but for this, my recommendation was to call down positive and up negative. But let's even say that you like a different recommendation, that you'd rather call up positive and down negative. Either one is okay, but either way, mg and kv better have different signs. That is what I am saying. Like, and this is a misunderstanding that comes a lot. Like, the point, let me just go to the next screen. What we're doing is this: we're saying sum up all the forces acting on a given axis, and they together will make acceleration. Like, it's always a sum of all forces produces acceleration. But the point of the diagram, the reason we make a free body diagram to see what to plug in onto the left side, is that from the free body diagram, like, even though we're always summing, the free body diagram shows that the two forces are acting in different directions. So they have to have different signs from each other. Like, it is ultimately a matter of taste or strategy, whether you want to say that the mg is the negative, or if you want to say the kv is the negative, that is your choice. But then the other one can't be. Like, they have to be different from each other because they're going in opposite directions. And whatever choice you make, the a has to point in the same direction as mg. Like, this thing is falling. So whatever we're calling down refers to, like, gravity pulls down, so it'll take the sign, and this thing is accelerating down. So whatever sign A gets, mg has to get, and whatever sign kv gets is a different sign from that. Within those parameters, you can do whatever you want. But in other words, I'm politely, definitely respectfully, I think it's a great question, saying though, no, I think kv, you either have to say kv minus mg. So actually, be very explicit. I'm saying the most strategic thing to do is to do this. The most strategic physics setup is this one. Or if you don't like that, because it is a little bit counterintuitive to call up negative, like people aren't used to that, you could flip it. You could say this if you like. And honestly, this is what I was originally doing, without thinking of it, because I could do it, but I don't like doing that, because if you do that, then you have to say this. And that's what I almost missed. Like, these two statements I just wrote, and this is to everybody. Again, this is what I mean by a good question. I don't care if implicitly their premise was true or false. It's totally generative of the right concern. I'm saying this option works. That's supposed to be a check, sorry. I'm saying the top option is correct physics. So you could use it to set up some math. And the bottom option is correct physics, consistent physics. You could use it to set up math, but it's one or the other, not any other combination. Does that make any sense? I forgot who just, was that Mateo or William? Does that answer my good stuff? I'm just gonna keep talking, I guess.
Yeah, yes. The answer. Sorry, wasn't working my mic.
No, my fault. No, I always do that too. Okay, good. All right, so I'm gonna keep going, and then I'll make a meta comment. So I'm gonna do it the top way, just because, you know, whatever reduces the number of negative signs is I'm in favor of. So I'm saying this. Well, I guess I'm just going to do, does anybody want to propose the next step? Like, I'm looking for V in all the wrong places, looking for V. That's ridiculous. I'm looking for V as a function of T. In my mind, I have a good idea of the next step I should do, but does anybody want to propose it? Or you could just date it. You don't have to marry it. Anybody want to suggest a next step from the breakout rooms?
Would you then convert V and go to dx over dt?
Oh, good. All right, another great contribution. Okay, yeah, that would be a good move. We're definitely going to do that at some point, and it's definitely smart because it's true. It'll start injecting the calculus into this. And yeah, I did suggest at the beginning that everybody take note of that fact. We are going to make use of that fact. However, I will say, I'm not going to do that just yet. I discussed this with one group in the breakout room. I don't want to do that just yet, because that will actually spoil the beauty of what I have right here. Like, the good news, like, what's smart about what he just said, and it is smart, is he's bearing in mind the ultimate objective here, which is to get x as a function of t. So he's trying, as he should be, to get everything like written in terms of x and t. That's absolutely smart thinking. Like somewhere here, we've got to get to x and t. So that's smart. And if he wrote that down as his next step on an exam, honestly, if the next step he substituted in dx over dt for v, I would give credit for that step. In my mind, I would start watching carefully to see what's going to happen next, because I've found out from experience that you can run into trouble doing that too early, so I'll just watch, but it's still a full credit thing to do. So yay. But here's why I'm not going to do it in public, so to speak, is that I'm so excited that right now already, oh, is my microphone, wait, can people still, maybe I'm not talking loud enough. I'm hoping people can hear me still, but okay. Oh, okay, something there. Okay. I am going to, it's so funny. Oh my God, sorry. I'm trying to do the physics, but also doing the, I'm trying to let people in also. This is so ironic, like, all right. I'm not going to substitute dx over dt for v yet, because right now the good news is I have literally one expression with two variables in it. One dependent variable, one independent variable. That's really what I want. Like, it happens that the dependent variable is not my ultimate objective. Fine, but I have a single valued function. That's what we're looking for here. And that's the good news. If I introduce x now, I'll have one equation with three variables in it, x, v, and t. And that I don't know how to solve. Like, for every one unknown, you need more information, you need an equation. So the mere fact right now that I have one equation with, in effect, one known and one unknown, I'm going to take advantage of that format, and I'm going to be patient with my x. In other words, I'm going to collect all the v's together and collect all the t's together so I can actually solve this. I'm going to say, oh, I'm going to do like what I think it was Antonio, did the other day. I'm going to take this differential equation, like that's what I have. That's what I was all about to say before. If this v were a t, it wouldn't be a differential equation, but it is a v. I've got dv dt related to v. That's a differential equation. What should I do? I want to integrate somehow something, but I can't integrate dv over dt. I'm going to multiply both sides by dt. So this starts to look like something integrable. Okay, I now have that. And I'm almost there somewhere, but now I've got, like, they almost look like things that could be inside integration signs. But on the left side, I've got t's and v's going on. That's ridiculous. Like, you can only integrate one variable at a time. So I'm going to divide both sides by that parentheses. So what I'm doing is collecting all like terms. I'm collecting all like variables. I'm putting all of the v stuff on one side and all the t stuff on another side. And I'm solving a differential equation just by trying to. So I have dt. In fact, I'm even in one step also. I'm going to divide both sides by m also, just to keep things balanced. Like, so there's not too much gunk on one side or the other. I now have this, right? And I'm saying this is what hopefully some version of this hopefully happened in some breakout rooms. Might be in a different order, but before we get into x, we're dealing with v, because here we have information relating v to t. So I have this on both sides now. Now, the left side is making a discussion of an infinitesimal bit of time. The right side is making a reference to an infinitesimal change or interval of velocity. And the only other variable on the right side refers to velocity, and there's no other variables on the left side. So I've got something, I can integrate both sides now. Like, I can integrate the left side with respect to t, and I can integrate the right side with respect to v. That's what I want. Again, it's like what happened the other day. So I could say, okay.
Wait, can you go back to the last page?
Sorry, yeah, absolutely. Sorry. Yes, absolutely.
If you divided both sides by mg divided by kv, how is there still an m under dt?
I was just going to ask the exact same question right before she said.
It's a great question, but it's because of the other m. I divided, maybe I'll do this in one. Okay, I'll do it in two steps instead of one. And I was going to, so I did two steps in one, but I divided both sides by mg minus kv, but I also divided both sides by m. Pretend that m wasn't an m. It's a funny coincidence that it's also an m, but pretend it was a lowercase b. Well, I'll do it in two steps. I'll show you what I'm saying. It's not actually, it's a great question, but it's not actually a mistake. Here, I'm going to back up. What we had was, yeah, we have dt. I think everybody agrees that we had this. right? Okay, we have this, and it totally is the same M. Don't get me wrong. This is a great question. The M that you see on the left side does refer to absolutely the same quantity as the M that's on the right side. But let me start by saying I can't cancel them out, right? I can't divide both sides by just M like we might want. Okay, I'll show everybody where the M came, or I'll back up all right, let me back up. Where did the M come from? It came from F equals MA. Like the physics of this is sum of all the forces acting on an object equals the acceleration of that object in a given axis, right? We're all in the y-axis here. So what's happening in the y-axis? We had the weight of the object pulling down, and I called down positive, so that was mg. We had the fluid drag pulling, or pushing, I should say, up, so opposite direction, so got an opposite sign, and that was called kv, or that is kv. And all of that together equals ma along the vertical axis. Like that's the physics. And then math-wise, we then said, oh yeah, okay, A means the same, it's triple equal sign dv dt. Like what does instantaneous acceleration means? It means instantaneous rate of change of velocity per time, right? So I substituted that, so that's where I got that. Now, this is where these guys' question comes in. There is an M on the right side, for sure. And there's an M in part of the left side. But I can't just cross those M's out or divide both sides by M, because like I only could if I had something like mg minus mkv. If there was an M in every term on the left side, then I could factor out the M from all those terms, and I would have like M times a bunch of garbage equals M times some other garbage on the right side. And then I could cross out the M's. But as it stands now, if I want to cross out these M's, I could do it only if I'm willing to divide K by M, which I don't think is going to make things any less messy. So the M's are sitting there. The M's are sitting there. Oh, did I forget? Yeah. Am I crazy? No, this is what we have so far, right? Right. So the M's are sitting there. So then I divide both sides. I multiply both sides by dt, because I'm trying to separate and collect variables. I want to separate the V stuff from the T stuff and put them on separate sides, because they are the two and only two variables. So I say mg minus kv all times dt, I'm multiplying both sides by t, equals m dv. Is everybody with me so far? I just multiplied both sides, unless I'm making a mistake. Am I good so far? That's, someone's entering the waiting room.
You're good.
Thank you very much. Thank you. And I'm about to, this waiting room thing is so funny. It makes me think every time like of a really un-PC joke where there's a doctor, the doctor, and he specializes in like growth issues and patients who are like midgets and underheighted and stuff like that. And he's got a great practice, and it's totally booming, and he's always overly busy. And the nurse is like, doctor, the next 50 people are in to see you right now. And he's like, not now, nurse, I have very little patience. Okay, that's so offensive. All right, going on. I totally did not say that. That was my, all right, so I have this so far. So now so I've got these M's on both sides. I don't think I can just get rid of them. I can't, but I can't. Oh, cool, I got it dead. I know what that means. Thank you for the, okay, thank you for that. I'll be here all week. I want to divide both sides by that whole parenthesis, mg minus kv, like not just the M part, but the whole thing, because it's a term that involves V. Like there's nothing else legit I can do to separate the V's from the T's. So I go like this. Okay, this is where I skipped a step before, or I mean, not illegally, but may have gone too far. Like I have this now, okay? Now I could totally leave this. This is fine. We can integrate both sides here as it is, but I'm just, again, with the benefit of hindsight or whatever, since this is just complicated enough, again, if I'm doing this for the first time myself, figuring this out, like the original physicist or mathematician, or if I'm learning this for the first time, there's a lot going on that right side. It's like very heavy with intimidating stuff. So just to clean things up and make it a little bit easier to deal with, like I now divide both sides by M, just so that I've got some constants on the right and some on the left, and that's just a taste thing. You don't have to do it, but it makes it easier to analyze for me that I'm going to divide both sides by M. But if you do it, then the legitimate way to do it is this. Like if you want to move that M, the only legal way is to then have And this is where I was a second ago, where I got those questions. Again, did those questions like go into the flow? Ooh, like, yes, I consider those very relevant questions. Those questions are not slowing me down in any way. They're totally like asking me to think carefully about this with everybody. So those are great questions. This is what I think I'm back now to, like, I think this is my answer to them. So keep them coming. So I now have this. Now, maybe this is intimidating or maybe not, but if I'm bearing in mind, like at the end of this problem, what I want is x as a function of t. But I'll tell you, I feel like I'm one step from there. If I can even just get v as a function of t, we might not be used to thinking that way. You might think like, go for x. But I'm saying the hard part is separating out these derivatives, getting rid of this derivative information and just getting to a simple function. That's really what the issue of solving differential equations is. Like, that's what we've been trying to reverse engineer the past few days, is if you're given derivatives, how do you unpack them and make them original functions? So if I can even just do that with v, I feel like then I could turn that into an x pretty easily, and I will. But but if I'm sticking with v first, I look and I've got one side is all references to time and everything else is a constant. On the right side, all references are to velocity, everything else is a constant. In other words, I've got the variables separated properly. Each side has a d blah in it, so each side is integrable. So I'm going to do just that. I'm going to integrate both sides. Right? That's like, so now each side of this looks like something you could imagine seeing in a math class. Of course, in a math class, it's like I mean, for good or for bad, you know how to, like, so let's just look side by side. Like the left side, in other words, the left side is really, you're just walking down the street and you accidentally open a door and you're suddenly in a math class and you walk in and they're like, all right, dude or dudette, what's this? Integral of 1 over m dt, right? And it's totally out of context, but this is what it is to be a physicist. Thought we were studying springs, I'm sorry, in this case, we thought we were studying like something falling in air, and suddenly we have integral of 1 over m dt. I barely remember what anything stands for in my mind. I don't know, what is this? But wait, this is a coherent question on its own. Like, this is a thing, integral of 1 over m dt. If it says integral of dt, I know that t is the variable of integration here, right? It's asking me to integrate something with respect to t. Oh, I don't even know the limits. Wait, is this even, it's an indefinite integral, right? The limits are not specified. So at the moment, I don't know them. They're not specified. It's an indefinite integral. It's the integral of something dt. Now, what's this 1 over m business? Well, if m is not the variable, then it's a constant, right? It happens to stand for mass, but I don't care. If I have to do the math of this, what I have is integral of 1 over a constant times dt. Well, constants come out of integrals. I mean, 1 over a constant is just some constant. I don't want to be intimidated. A constant divided by 1 or 1 divided by a constant is just, in other words, this is the same as just being asked this, right? If I just deal with these things step by step. Now the integral of dt, it's out of context, but if it were a math class when you were learning it, you know it's almost the simplest integral there could be. I mean, in effect, this is the integral of 1 dt. It means, what do you get when you add up? If you add up an infinite number of infinitely small intervals of time, what do you get? And you get the whole collection of time, the entire second. That's what you get. In other words, you get t, right? Like, going on to the next page, I'm saying 1 over m, an integral of dt, if it's an indefinite integral, what you get is t, well, times that constant over m, plus, we'll call it c for constant. This is one of the reasons I didn't use the c before, but whatever, right? That's the left side. This is the left side. So that left side, so in other words, t over m plus c, I don't know what c is, it's an arbitrary constant because this was an indefinite integral, equals now the right side, a little more intimidating, but same idea. Right side is dv over kv minus mg. All right, so I'm now focusing on that. So I could view that as, in other words, what it is the integral of 1 over kv minus mg all times dv, right? I mean, just to be clear, like, this is just a good old-fashioned, some kind of integral you could see in a math class where the variable is v, and v is mentioned only once in the expression, and everything else that's mentioned is a constant, so there's nothing actually too crazy about it. But it's a little annoying because v is in the denominator, and it's embedded in this expression. So, you know, this you have to have a little experience integrating. It may not be the first integral you want to jump in and solve, but it is integrable, and it's not that bad. What I hope please stop me if you're, but like I'm gonna keep going. Like this how do I solve this? I do U substitution. I love U substitution because they make sense to me. Like it's something you I think could think of on your own, and you don't have to remember. It just makes sense. In other words, I'm going to say, well, I'm looking for V. It's all about V, but V is embedded in this expression that's underneath, and like I can't. So let me take that whole expression. When I'm trying to integrate that right side. This is a math moment. I'm trying to integrate the schools in Alabama in 1960. No, I'm trying. That's so inappropriate. I'm trying to integrate this. And right now I'm writing it in a way that makes it look the most like some math integral. You know, when I just put the dv on top, that's the simplest way to write it, but you may not recognize it. So I'm trying to integrate that. So I'm going to say, and this is just me talking to myself, right? I mean, like there's no rule in a book that you have to do this, but to me it makes sense to say, all right, from now on, instead of that whole kv minus mg thing, I'm going to say that whole thing I'm going to call u, because it's really annoying that there's all of these complicated details surrounding my V that I'm trying to look at. Well, if U stands for that whole thing, then if that's true, then du dv, right? Like if I take the derivative of both sides, what? I thought we were integrating. Yeah, well, I'm taking the integrals are sums of differentials. I'm taking the derivative of both sides, du dv. It means I'm taking the derivative with respect to V. You'll see why in a second. But the derivative with respect to V of the right side of that is K. Oh, is just K, right? It's K minus 0 technically, but du dv is K, right? And stop me if that's not true, but I think it is. Yes, du dv is K. Why do I care? Because if du dv is K, then that means dv, and my u's and my v's look sadly similar. Sadly, oh, sorry, question? Oh, no. dv then equals K over du. Where's he going with this? I know, fair, but here's where I'm going. I'm doing a U substitution to solve this integral so that I can get V as a function of t, and I'm about to make use of my U substitution. I now have that from now on, everywhere in this thing where I see kv minus mg, I'm just going to put a nice simple U in, and that means wherever I see a dv, I'm going to put in a K over du, like, right? I mean, I'm making a U substitution. I'm changing a variable. That means I have to change it. I don't want to introduce a third variable here where I don't have another equation. I'm making a sweeping change. So I need, if I'm going to do a U substitution, I have to have a translation code, not only for the original kv minus mg, but I have to have a way of dealing with that dv. And I do. Where I see dv, I'm going to substitute in K over du. In other words, I'm trying to integrate. Next page.
Good question.
Oh, sorry. Yes.
For du over dv, did you just arbitrarily say that's K, or did you?
No. Great question. I'm sorry. Whoa. Great question. It's not arbitrary, though. Great question. What I did was I looked at u as a function of v right here. I'm saying if u equals kv minus mg, that's like saying y equals mx plus b, and then asking, I mean, what I'm doing is like saying, all right, say y equals mx plus b, what's dy dx? And it would be, I'm literally taking the derivative of the right side, treating v as the variable. I'm taking the derivative of u with respect to v. So v is my variable. And I'm saying, oh, the derivative would be the derivative of kv minus the derivative of mg. Well, the derivative of kv is k, like from the power rule or whatever. Like that's just, and the derivative of mg is 0 because mg is a constant. So that's a great question. That's so loud. That's a great question, and it's something I often, you're quite right, that I often will suddenly say something like, let blah blah equal k, and it'll be arbitrary. If something is arbitrary, like a designation, I'll try to use a triple equal sign, like I'm doing here. Like I just made up that u equals kv minus mg. But if it's true, if it does, then du dv definitely equals k, because I took the derivative. Does that make, oh, did I make a mistake? Oh, sorry, wait, sorry. And then someone has a correction. I'm sorry, wait. Everything I just said is totally true, and I'm going to repeat in a second. I'm literally saying k equals du dv by taking the derivative, but then it's true. Then I did the math wrong. Sorry. Then if I multiply both sides by dv, I mean to say, sorry, that dv therefore is du over k. Someone just corrected me in the chat, and that's totally right. Thank you. But so let me see. But that question is great. And I forget who, I think it was Ayeta, but wait, so I can't, so we're good, are we on the same?
Yeah.
And then if someone just chatted me the final answer, you're probably right, but I can't, I'm having a hard enough time catching up with everybody. So hold on. If you're at the final answer, great. You'll know in a second if you're right or wrong, but I'm saying so far that we have this. I'm saying we're trying to integrate this right side of what we have, right? This is, in a way, it's like a sidebar within a sidebar within, but they're not sidebars. They're all like submission within submission, sub-goal within sub-goal. So far, I'm saying, well, this then, we're going to substitute u for that. I shouldn't have used u, I suppose, because it looks too, and we're going to substitute for wherever we see dv, we're going to substitute k over du. Did I do this? Du, no.
The opposite, I think.
I just did it again. Thank you. Did it again. We're going to substitute. Oh my God. Right, we're going to substitute. Yeah. Wait.
Du over k.
Do I believe that? Yes. Thank you. Yes. Du over k. Thank you. And I was just doing that to see if you were paying attention. No, I totally was legitimately screwing that up, but thank you. Yes. So we have that. So I'm going to say now our integral reduces to, this integral that we're looking for reduces to 1 over u times du over k. That's what we have so far, right? Like we just took an integral that is intimidating. And what we would do is we reduce it to something that we already know how to do. And what we're doing when we do that is not condescending to ourselves or like being students. Like this is how physics is done, right? Like this is how physics is invented, is you constantly have to just take things that you don't know and relate them back to things that you do. It's not, that's how we're trying to manage the world. So we have this now. The key is that u is a variable, k is a constant. So in effect, what we really have is this. Right? Now this is a simple indefinite integral. Like the answer to this, I think you have to know it from, you have to have done some calculus, and this came up 2 days ago, but the answer to this is not like u squared over 2 or something like that. Like this is the integral of u to the -1, in other words. And the answer to that, oddly, I think is natural log of u, technically of the absolute value of u, natural log of u, times 1 over k, because that's a constant that's just sitting there. Sorry, hold on a second. But the answer to this is this. And then this is all an indefinite integral. So technically this would be plus some constant that is not necessarily at all the same constant as we found on the other side. So I want to call this something like C2 or something if I'm being careful, right? But this is the answer to the right side. And you might know this answer at this point, but I'm here to, like, the point is not to memorize that this is the answer to the right side, and nor is it even to memorize any of these steps, right? Like, just like once you know these methods, hopefully you're confident that you can call them into play when necessary. We now have, well, I had to do all that to get to saying, okay, remember this all came from physics. Physics that was saying, physics was saying this is what the physics was saying. Right, we had something like that. And now the left side we said was T over M plus C. And the right side we're saying is, well, is this 1 over K natural log of U, U, plus C2. But what the heck was U? Like, that's not, U was an expression that we made up for something legit. Let's put it back in here now so we can stay legit. The whole right side is natural log of KV minus MG. Okay, and then plus we have this crazy other cost on the right side, and you can't read my handwriting because it would be offensive to say axe murder in class, therefore I won't say it. But this is what we have so far. You might say that this looks way messier than anything we had to begin with. Like, it really might look like, what is this? And this is all a sidebar? Like, why is everything now exploding in my face? I thought we were at, but it's not. It looks like an explosion, but it isn't, as long as you recognize still all we have here is V and a bunch of constants on the right side, and T and a bunch of constants on the left side. Constants
make messy looking things, but they ought never intimidate us. Constants are constants. The right side has a v, the left side has a t. So we're almost at some kind of function here that's like usable. What do I forget? First thing I want to do to figure out this function is, I've been very careful. I'm saying these are indefinite integrals. We don't know what interval of space or time or whatever we're investigating. So we got an arbitrary constant on the left. Arbitrary means we don't know what it is, but whatever it is would stay same for a given problem. And we got a different one from the right, like meaning that they might be the same, but there's no reason to believe they automatically are. They are two different constants, C and C2. However, they're just two different constants. You could subtract C2 from both sides, and you should. You should. If what I'm about to say is just like a physics trick for math that once you see it, you do it all the time. But if you've never seen it, or you don't know what it is, it can look weird. I'm saying let's subtract C2 from both sides. So we'll get this. We'll get T over M plus C minus C2 equals all the. I'm trying to clean things up now because everybody loses sight of what's going on. We're trying to get new handwriting. We're trying to get V as a function of T, right? So I'm trying to clean up these constants that are in my way. So the first thing I did was subtract C2 from both sides. So now on the left side, I have C minus C2. I have T over M plus, like I could even put parentheses, right? Plus C, some arbitrary constant, minus C2, some other arbitrary constant. In other words, T over M plus some number that I don't know, but is a number, minus some other number that I don't know, but is a number. Well, I don't know what either of them is. So isn't it really true? Isn't it true? And yeah, I'm going to the next page. I can go back in a second if you want. Let me make up a third number if I want called C3, which stands for, a third name, which will stand for C minus C2, right? C is a constant, C2 is a constant. One constant minus another is just yet a third constant that I still don't know what it is, but it is a number. So I'll call that C3. In fact, if it's the only one in town, if C3 is like the combination of C and C2, that just is some number that I don't know, I don't have to call it C3 anymore. I could just call it C, right? In other words, I'm saying now, I had a constant on each side, and I have to recognize that each of those constants didn't have to be the same thing. That's why I tracked them. But now that I'm looking at my expression, having tracked them carefully, I can track one of them out of existence because any combination of constants is just a constant. Therefore, one simplification, therefore, what we have so far is, like, in other words, I only have to put the constant on one side, really, when you think about it. So what I have now is this, okay? There's an interesting latency on, okay. I'm watching my, okay, yes. We have that so far. Don't be intimidated, but, I was just told my internet connection is unstable. It feels like a psychiatric diagnosis, actually. Like, I'd love that. I would save so much money in therapy if just like while I was working, all of a sudden the mirror would just post a sign that says, your mental state is unstable. What happened to the 1 over K? Oh, thank you. Great question. What happened was I just totally forgot about it. Like yesterday's news. So cruel of me. Thank you. You're absolutely right. I believe it goes right here, but I don't even remember. Hold on. Oh, yeah, I believe so. Yes, thank you. Absolutely. Totally appreciate that. I forgot the K. So now I have this, and it just goes to show you chat works. Chat works. And FNet equals MA brought to you. Yeah. Now I'm saying, like, and someone's asking, so I did this business with C3, and then someone said, but shouldn't you leave it C3? Wait, don't call it C because you're already using C to mean something. But I'm saying this is the beauty. You got to watch what I'm doing because it doesn't look right when one first does it. But it is right and helpful. I'm saying, yeah, I was using C to stand for arbitrary number that I don't know, but I know has to be there. Now I'm saying there's still only one of them. There's only one of them. So let me just keep calling it C. Like, in a way, what C now means is my old C plus some other, it doesn't matter. There's one number that I don't know. So I could call it C3, but that would make it seem like there's 3 things I had to figure out, and I don't anymore. I just have to figure out this one. So I'm calling it C. Like, that was a great question someone just sent me, but that is my answer. Let's just keep seeing what's happening. But then someone else also pointed out that there's a 1 over K. This is the other great thing. I think maybe this is why sometimes people ask privately, you never quite know when if you think you have a question in physics, you never quite know whether you're admitting that you don't know something or are confused, or whether you're catching the professor in an error. And of course, there's satisfaction in each, but you never quite know, and that's what's weird. But let's all of us always assume that there's a good chance you are catching me in error, and then you're doing everybody a favor, and then you look like a cool badass, and even if I look like I can't handle it, I only am that much more impressed with you. So that is not, don't be afraid of catching me in an error, because better to catch it and point it out and have it sit anyway. So we have this so far. The 1 over k I dropped accidentally, but there it is. But now k is still a constant. K is a constant. So I'm going to do this move again now. The move I just did with constants, I'm going to do again now, but slightly faster, and see if people catch on. Like that 1 over k is sitting there, and it's annoying me because it's a constant that's in the way of the information I want, which is variable information, like I'm a scientist. So I'm going to multiply both sides by that k that I had almost forgotten about. So I multiply both sides by k. What I should get is kt over m plus kc. Like I should distribute the k over the left side, and then get equals natural log of blah, 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 right? And that's correct. Now I'm going to go to the next page, but I'm going to say now, well, I'll write it, but I'm going to write that again, just writing it so we can look at it. I have kt over m plus kc equals, I don't even remember anymore, equals, oh yeah, natural log of kv minus mg. So this is what I have so far. Kt over m plus kc equals natural log. And those k's are the same. That k means the constant that has to do with the aerodynamics of the situation. Now, I could factor out a k from the left side and divide both sides by k, but that would bring me right back to what I just did. No point in doing that. That just completely messes the clean. Oh, and we're almost done. I see that too. But I am going to say this. Kt over m is what it is. But kc means some arbitrary constant called c times some other arbitrary constant called k. So kc doesn't equal the original c, that's true. But the original c, I never knew what it was. It was just some number that I had to track, that so I had to know was there, but I don't know what it is yet. So in other words, this is a bold thing. I'm literally going to do, again, what I just did a second ago. I'm going to say what I really still have here is, I could call this, I could call, I can make up a fourth constant, which is the value of our old constant times k, and call it C4. But then it's still going to be the only constant in town. Why call it C4? It just intimidates me for no reason. I'm going to call it C. Now, this means C did undergo an identity crisis. Originally, when I was saying C, I meant some number that I didn't know. And now by C, I mean some number that I didn't know multiplied by some other number I didn't know, divided by some other number I didn't know. But I don't care because I don't know what all those numbers are. So C is still C. This looks like an illegal math move, but it's actually not. This is why there are physicists, I suppose, in the world. So now we have this, and we're almost somewhere. Where is the end of class? And I'll get back to the by the way, none of the homework has anything to do with the vectors, and whether or not the vectors are on the test, you'll find out. Just tonight, catch up with everything we're doing, because everything we're doing has to do with this right here. So the vectors are just on hold, and this will finish in 1 second. We got some function of t equals some function of v, okay? On the right side, we're looking for v. I want v by itself. I want v as a function of t, so I can end class for you shortly, and so that I can get from it to x equals ft. So what do? I'm going to inverse function the logarithm on both sides. Like the right side doesn't have v, it has the log of v. I don't want the log of v, I just want v. How do you undo? Well, natural log is the inverse function of e of the exponential function, right? I'm saying this fast, I'm assuming that like I can reinforce this tomorrow, but it is math. In theory, we know it's very cool math. In other words, I'm going to raise e, I'm going to take e to the both sides, so to speak. I'm going to go like this. E to the, but there's a minus sign missing somewhere here. I think I dropped, I think I dropped a minus sign. We'll find out in a second, but either way, well, actually, no, let me look for 1 second. Yeah. No, I guess not. Just want to make sure I didn't try. Oh, have I been doing? Oh, I've been doing exactly the thing I asked myself not to do. I've been writing KV minus MG the whole time when I specifically asked everybody to say MG minus KV. I do this every time. Hold on 1 second. I'm just looking back because I want to end this right. It's just going to make the difference of a minus sign. But that's exactly why I asked everybody. All right. You're going to see an inconsistency in your notes. I keep yelling at everybody to recommend doing mg minus kv to make that, but I keep instinctively doing it the other way because I'm instinctively thinking up is positive. Either way should work, but you got to be careful. In other words, if we're doing it this way that I am, then I'm going back and forth. Notice, right, they're really right. The way I'm doing it with, if gravity is pointing down and if negative in this way, then right from the start, one thing you have to correct, I'm sorry, it's not, won't mess up your notes, but you'll get this if you're paying attention. I'm saying right from here, right from the beginning, if mg minus kv equals, that's true. Wait a second. mg minus kv, mg minus kv, mg minus kv. Yeah, see somewhere I flipped it right here on page. I'm sorry, everyone, but it says dt over m equals dt equals dv over mg minus kv. And then the next page, I know I'm going fast, but just look in your notes where I am. Right after that, I just swapped the kv and the mg for no reason. That wasn't like some math cool thing. That was me making a mistake. Please, and it's just going to mess us up by my sense. So please correct from there. It doesn't change the calculus or anything, but it is an error that I just caught. So swap the mg and then that will change that. It doesn't change it that many places. I know I'm going fast. You're going to have to look at this recording or whatever. I'm doing this to make you stay on your feet. No, not at all. I'm doing this because I'm human. Well, because I'm a special kind of human called inefficient and bad. I will punish myself properly. I promise. I will say Hail Marys. And I'll even say an additional Hail Mary for being Jewish. Okay, we have that. So I corrected, these are corrections. Please follow me, we're almost done. Yep, that has to be swapped to. This is, I just noticed this because I knew something bad was happening with a minus sign. So this goes like this. At least the person who asked me, when I send you the PDF of this, of course, it'll just be correct in the PDF. Okay, all right, now. And please tell Professor Wu if I'm keeping you over for a minute, please tell him it's my fault and he'll believe you. Right, so that has to be MG. Okay. Of course, secretly, everybody should be ashamed for not catching this. No, there's probably 100 private chats where you all told me this, and I'm sorry I missed. Okay, we're almost there. Well, I'm gonna take it for granted that you can catch me. Okay, here we are. Here. I'm not going to do it every one. I'm going to take for granted you can do the middle. But we have here mg minus k. Okay. Again, we're almost done. But I'm going to take now the e of both sides. And this is where I am. I'm back on this. I don't know what to call it. Page. Oh, you can see the page. Page 37 of the notes. So I'm going to take e. After all that, did that even? Yeah, all right. So
I have a question. Like if you change it, if you swap it to mg minus kv, wouldn't it change it so that when you take the integral, wouldn't it be negative 1 over k?
Thank you. Beautiful question. Perfect. Because that's actually what prompted me. Yes. And thank God. And that's not enough. She's absolutely right. And that's good because that means all the corrections that everybody just did was for a purpose because it allows us. She's absolutely right. And that's what I was looking for at the last moment. She's saying that when I take the integral of the right side, it's really, she's saying right here on this screen, when you take the integral of, and again, I apologize for going a little over, but we are going to finish this properly. The integral on the right side, dv over kv minus mg, if that's really mg minus kv, she's saying, and this is a very welcome, we need this correction, otherwise this whole thing was going to blow up. If we have that, then she's saying there's really a negative sign that comes out from chain rule or from U substitution. Absolutely right. Absolutely right. Thank you. $100 points. So there's a negative, I'm going fast, but yes. So there's a negative, and these both should be mg minus kv, absolutely. That's the same, I mean, just so people don't all of a sudden have a crisis of faith. What she just added was a consequence of the same error we're all erasing error. I don't want anybody to think there's like a million errors going on because then, you shop for another sedan or something.
Shouldn't you also change the second K on the last line?
Ah, in theory, yes, but that's great too. But then that's the same thing as what I'm saying. Like I could, but then it just means negative. It means minus some constant, but I never had to specify that this constant has to be like, in other words, I still don't know what the constant is. It could be a negative number. So I don't have to do that for the same reason. I could just let C5 equal negative C and then, but you're right, technically I could, but I can just leave this. Either way is fine, actually, but that's a great observation. Now, for the people that definitely need, well, for everybody who needs to go, what I'm saying is, I'm just gonna write that last step. This is what I have so far after all the erasures and everything. I think what we have is negative KT over M. Then you can say minus C if you like, but I'm gonna say plus C, right, equals natural log of mg minus kv. I think this is what we have so far. So now I'm gonna raise e to the both sides, so to speak. Wait, let's look at the chat. Again, I know I'm taking you over. Hail Mary for the, oh, that's cool. Hail Mary for the correction. Yes, I think I get that. I'm all about Hail Mary. Okay, so we're gonna raise e to both sides. So we have e to this monstrosity, negative kt over m plus c equals e to the natural log of mg minus k. In other words, function of the inverse of its own function. In other words, the whole purpose is I'm getting rid of, and you could technically say absolute value, but in a minute, it's not even going to matter. It doesn't really matter anyway because we don't know the value of the constant. So I'll say that. So we have this still monstrosity, e to the quantity, negative kt over m plus c, or you could say minus c if you like, or you could even say minus c over k, it doesn't matter, all equals mg minus kv, because the absolute value thing hinges on the c for the same reason. Now, what do I do with this? Well, this, I love this. This is worth being late for, because now I could say, well, I mean, e, notice that like e to the something plus something necessarily always is the same as, right, from math, like any, well, I'm just saying, I mean, we can go over again this tomorrow, but e to the power a plus b is the same thing as e to the a times e to the b. In other words, what we really have is e to the negative kt over m times e to the c. And again, you could say negative c, but I don't know what c is, so I don't think that's worth it. All that equals kv minus, no, it doesn't. All that equals mg minus kv, okay? And now why did I bother to make that? Well, that means I have e to the negative kt. T is a variable. T is a variable that I'm focused on the left side. But all of that e business times e to the c times the crazy number e raised to some number that I don't know. Well, I don't care how crazy a number e is. It's a number. A number raised to a number I don't know is just a number, right? So literally, actually, all of this left side reduces to this. E to the c is just some freaking number that I still don't know. So I'm just going to call it c. And it's just a coefficient, or I mean, a constant that's being, a coefficient that's by which e to the negative kt over m is being multiplied. All that equals mg minus kv. Almost there, because we're looking for v as a function of t. Everything that isn't v is a constant. So even to make this even more clear, maybe I'll just swap the left and right sides, just so we're focusing on looking for v in all the wrong places. Okay, wait, so we have this. Right, so we're looking for v. So maybe, so I'm going to say kv equals mg minus c. I have this, right? I just rearranged, just added and subtracted from both sides, trying to isolate the kv thing by itself. So then I can divide both sides by k. It all seems like we're going in circles, but we're not. Every single, besides my mistake, every single step is actually a forward step, none, as much as it may not look that way. So this is worth going over each other. And yes, this will be on exam. It's not a sidebar. You'll get credit for understanding this, but we now have, and I know we're really, Wu is going to kill me. I know, or I apologize. And if you have to go, just go. You'll get this. No, I'm going to do this on the next page. We have K V. sorry, kV equals mg minus c e. This is why people don't deal with air friction on day one of physics, but this is also to show that you totally can deal with air friction. It's like not beyond us. All right, so we have this, looks crazy, but divide both sides by k, and we got V equals mg over k, okay, minus, you could say c over k, e to the negative, but c over k is just a constant. So I'm just gonna keep it c. See, it's so powerful that you can do that. And everybody hates it until they love it. It's like physics or life. So we have this so far. Oh, this is like almost an answer, almost. This is V as a function of t, right? Even if it looks intimidating, it's V as a function of t. We're one step from X as a function of t, right? And I know, but the only problem is there's still that C that I've been carrying the whole time, Like I now finally have to deal with it. The good news is I kept it, one bundle of things I don't know, C, but I still don't know what C is. I would have if the limits of integration had been specified. They weren't, but that's because it was a physics problem, not a math problem. I'm gonna say something now that I'm gonna say again tomorrow and make you write down, but if you can catch it now, that'd be good too. Any arbitrary constant from math, or oh, shouldn't the k be divided? Did I mess again? Yeah, but I'm saying c divided by k is just some number. Yes, but no. Great question about the k, but think like I'm saying let c. You'll think about this, but c divided by k is equal to just c. That's the beauty of. You'll see in a second if you think about it. But what I'm saying quickly now is c came from the fact that nobody specified the limits of integration as it was a set up math problem. But they tacitly did, if you think of this as a physics problem. The limits of integration are like the boundaries of the problem. In physics, those are called boundary conditions or initial conditions. In other words, whatever we know about the beginning, like when I usually give you amplitude or something in a spring, or I give you the initial position, like however fast this thing was originally going, call that V naught, right? That's whatever velocity this thing had at time equals 0. Maybe it was 0, but maybe it wasn't. But whatever it is, just call it V naught, right? Then we can figure out C. If you know the initial conditions, it's like knowing the limits of integration. We can know C, because if V naught is what we mean by the initial velocity, then we know that 0 must equal mg over k minus c e to the negative k0, right? Oh, I'm sorry. We know that v naught at the velocity at time equals 0 is whatever we call initial velocity. V naught must equal mg over k minus c e to the negative k. Oh, what's e to the 0 is 1. E to the 0 is 1. So we know that V naught equals mg over k minus c times 1, right? So what c is mg over k minus V naught. Did I do that right? Yeah. So our answer, our function is, and let's even imagine, because we have to wrap up it, imagine, just to make this simple, imagine if V naught is really simple, like 0. Like imagine we're talking about from rest, just so we could see the math really fast, and you could plug in more complicated things later if you want. If V naught is 0, then C equals mg over k. Again, all of you who are late for lab is all, right, I think I have left it. So it's all of you. So he'll understand, blame it on me. He'll know this happens. I apologize. But if it's another class, I don't know what to tell you. Then we're saying C equals mg over k minus 0, right? So it equals mg over k. So our function that we found, then V equals mg over k minus mg over k e to the negative kt over m, right? That's what V is. Looks complicated, but it's just some constant minus a constant times an exponential function, right? That's what v is. What we wanted was x. Now we can integrate. Like this is now not a differential equation anymore. This is something we can just literally integrate because the variables are in the right place, right? So in other words, and this is the last thing we're going to do, in other words, dx dt equals, I owe you, I know we have to get back to all these homework stuff. You're now way ahead of me, you class, because I just did all this and I added to our stack with this. I know it, so there's not anything new for a while. But this is, I think, if you follow this, you'll know you're really getting the ins and outs of physics and calculus. We have this now. This I can integrate. Well, I multiply both sides by dt. And I could factor that out, but there's a reason I'm not. It's actually not going to make things easier to factor it out yet, but I certainly could. Multiply both sides by dt, integrate both sides, and we're going to get x plus a constant on the left side equals, well, mgx, okay, minus doing this fast now, and we're just about to, you get a constant on the left side. You don't have to put another constant on the right side because everything we just said, but I just did, you know, integral of e to the x is e to the x, but I did a u substitution quickly so I can get backwards. And we get cancellation, we get, oh, sorry, this is supposed to be k over, I'm sorry. Okay, so we get this. Sorry. Sorry. No, transfers. Okay. That's a T. Okay, all right. Anyway, we are going to pick up from this next time. I wanted to at least get to this answer. Now you could factor something out here. This answer doesn't look pretty, but it is an answer and it is analyzable. I wish it looked prettier for all the amount of time we just spent on it, but that's not actually important as much as, and I'll correct the answer too if need be when we meet. What I'm saying though, the point of all this, in the end of the day, once you throw in air resistance, it doesn't make the physics impossible at all, but it does make for a feedback phenomenon that makes for exponential dynamics. Like when something falls in air, its acceleration is not constant anymore. Its acceleration changes, and the change in the acceleration changes, and the change in the change, et cetera, et cetera, et cetera. The simplest way to describe something falling, and I think there's one error with one of the constants here that I'll correct it, but it mainly the answer does look like this. When something's falling in air, it's totally dealable physics, but it is exponential function, not an algebraic function, precisely because of the feedback phenomenon that's set up between the velocity of the object and the force exerted by the air. This is just like simple harmonic oscillation in that it's a differential equation that is solvable, but it's solvable on its own terms. Like, I think this was long. I saw quickly in the chat, someone said, didn't see this one coming or something. Yeah, it's like, whoa, it's a bigger deal than I thought. But each step is completely doable with methods already in your brain. You just wouldn't have known that they could be that useful. And what you end up doing is solving a differential equation, in this case, with a lot of steps, but with some ease, because it's a it's a first order differential equation. It's the first derivative of something is related to something else. Again, we'll analyze this more because I want to clean it up and have it be more rewarding. But if you follow this, then you see what we're doing is this with our harmonic oscillators, only we keep slamming against cosine functions there because those are periodic function phenomenon, a different differential equation, and actually a more complicated one, but the one that the physics demand. That's what we're doing mostly in class. All right, I will get back to all the vectors and all of that tomorrow and our exam. I'm very sorry this took so long. You should go. You all should go. I'm gonna hang for 2 seconds and look at the chat and stuff and maybe try to answer questions, but way too long. And Professor Wu is good. Yeah, anyway, please, I'll apologize to him, but let me look in the chat. Okay, the K being divided, if I think I addressed. The K, you could divide both sides. Wait, okay. All right, looking at the chats, I'm not sure if people are happy or sad about this calculus. I hope ultimately happy. I'm not sure I can address Eddie's thing is funny, but I'm not quite sure. But yes, I do have to warn you, all this calculation that we just did right now, it takes longer because I'm explaining it while we go, for sure. Like, I'm teaching it, so it takes longer, but it is a lot of steps. And yes, the thing about the exams is, this is what you do on the exam, is this kind of stuff. Now, the good news is on the exam, you will have seen it already for the most part. Like, I would never ask you to, out of fresh thoughts, just come up with all of this on your own. But you are able to come up with this kind of stuff on your own the more you practice being able to do it at all. So yeah, like, I would ask a problem like this on the exam and you would have to do all these calculations. Again, you will have practiced by then, but yes, it's a fair, and I think I'm the only one talking. I think I'm talking to just myself now. Okay, right. Well, that was fast. Is anybody here? Oh, people are here. Wait, are you guys here? I don't even know who I'm talking. Oh, so I am talking to people. Okay, sorry. So yes, you have to do this on, I think, someone's waiting outside. So those of you who are left, I am sorry to stay so long. Do you have any, do you want, those who are left, do you want to ask?
Is this an equation that we're technically deriving and will be able to use from here on out, or is this just only for this particular example that this would be applicable?
Right, that's a good question. The final result of this is only applicable to fluid drag. This final equation you wouldn't want to memorize for anything else in our class, or like, you would be tested on this, but you're right, you can't use this result anywhere else in the physics. That is true. That's right. Like, this is an example and it's useful in its own right, but it's not. What's useful is the beginning steps. The final steps you would not want to. Plus, honestly, I have to clean up this final step anyway. But no, right, don't memorize the final step or anything like that. That's right. Any other questions?
Thank you.
Oh, thank you very much. Thank you.
Thank you.
Thank you.
Good boy.
I think good boy was to a dog, not me. So if you guys are good, I'm good. Good, we're good. I'm just here just in case, but if you're good, I'm gonna go. So you guys are good? Good. Great. And Grace, you and I are good with the device thing. Rabina, oh, why is it? And Rabina, I understand about the phone. That made sense. Megan's a guest. I don't know what that means. Rabina, guest. Wait, guest? Why would it be? Oh, everybody's a guest. And I will post everything. Yes, I will post. Yes, I'll post the lecture. It should be in a few hours. Yep. Assuming you saw the other ones. Get towards the end. Thank you so much. Awesome. Awesome. All right, so I think we're good. So I'm gonna post everything. Practice again may come late tonight, but it'll come. All right, you all are amazing. Thank you very much. Pleasure.